Think for a moment about your daily life. The smartphone in your pocket, the car you drive, the complex medicine that keeps you healthy. We are surrounded by the marvels of modern technology. It's easy to look at these achievements and feel a sense of superiority, a belief that we are living in the most advanced era humanity has ever known. But what if I told you that this narrative is deeply incomplete? What if many of the innovations we proudly claim as our own were not just imagined, but actually built thousands of years ago by people we often mistakenly label as primitive? This is not just a speculative thought. It is a historical reality that challenges the very foundation of how we view progress. Welcome to a journey that will redefine your understanding of human history. We are about to explore 35 astonishing examples where ancient history was so far ahead of its time that it feels almost like science fiction. We will travel back to eras when master engineers constructed machines powered by steam, when early physicians performed complex brain surgery, and when brilliant astronomers calculated the movement of stars with jaw-dropping accuracy, all without the tools we consider essential today. These are not isolated accidents or lucky guesses. They represent profound pockets of knowledge, moments of brilliant insight that flickered brightly before circumstances, or even time itself, seemed to conspire to extinguish them. This story is about the incredible ingenuity that existed long before our modern world took shape. So prepare to have your perspective shifted. We will uncover civilizations whose achievements were so advanced they were often lost for centuries, only to be rediscovered and labeled as modern inventions. This exploration is more than just a list of curiosities. It is a testament to the boundless potential of the human mind. It is a celebration of those moments when our ancestors looked at the world around them and dared to dream bigger than anyone thought possible. Get ready to discover the secrets of the past, because what you are about to learn promises to challenge everything you thought you knew. Our first stop takes us to the bottom of the Mediterranean Sea, off the coast of a small Greek island called Antikythera. In the year 1901, sponge divers stumbled upon a shipwreck, a Roman cargo vessel that had sunk around 70 BC. Amidst the broken pottery and statues, they recovered a lump of corroded bronze and wood that seemed so unremarkable it was almost overlooked. For decades, it sat in a museum storage room, a curious artifact that no one could quite understand. It wasn't until the 1970s, with the advent of advanced X-ray and gamma-ray technology, that researchers finally saw what was inside that calcified lump. They discovered a complexity that shattered our previous understanding of ancient technology. This was the Antikythera Mechanism, and it was, without exaggeration, the world's first known analog computer. The device was a masterpiece of precision engineering, a compact clockwork universe made of at least 30 interlocking bronze gears, all housed in a wooden case no larger than a shoebox. Intricate inscriptions covered its surfaces, serving as a user's manual for the cosmos. By turning a hand crank on the side, the gears would move in a complex, synchronized dance, driving pointers across dials on the front and back. These dials didn't just tell time, they displayed the positions of the sun and moon, the phases of the lunar month, and the movements of the 5 planets known to the ancient Greeks. It could predict solar and lunar eclipses with remarkable accuracy, and it even accounted for the irregular orbit of the moon through a clever system of pins and slots that mimicked the physics of elliptical motion. This wasn't a simple calendar, it was a portable, mechanical representation of the heavens. The profound significance of the Antikythera Mechanism lies in its isolation in time. This level of sophisticated mechanical engineering, with its differential gears and intricate calculations, would not be seen again until the development of astronomical clocks in Europe during the 14th century. That's a technological gap of over 1,300 years. Its existence forces us to completely reconsider the capabilities of the ancient Hellenistic world. This device didn't emerge from a vacuum. It implies a long-lost tradition of scientific instrument making, a school of mechanics and philosophers who understood the universe as a complex, predictable machine. The identities of its brilliant creators remain one of history's great mysteries. While many scholars link it to the legacy of Archimedes in Syracuse or the intellectual hub of Rhodes, we may never know the specific genius who designed it. The Antikythera Mechanism stands as a stark, haunting reminder that technological progress is not a straight, inevitable line upward, but a path with peaks and valleys, where brilliant lights can shine brightly only to be lost to the depths for centuries. While the Antikythera Mechanism reveals a staggering level of mechanical intellect, our next example showcases an ancient material science so advanced that our own modern infrastructure is still struggling to catch up. Let's turn our attention from intricate gears to monumental architecture, specifically to the heart of Rome and a building that has defied the ravages of time for nearly 2 millennia, the Pantheon. Its famous, unsupported dome, a perfect hemisphere of concrete, remains the largest of its kind in the entire world. It has weathered earthquakes, invasions, and constant environmental stress since it was completed under Emperor Hadrian around 126 AD. Meanwhile, many of our own modern concrete structures, from overpasses to parking garages, often show significant decay after just a few decades. This stark contrast begs a simple, powerful question. What secret knowledge did the Romans possess that we have somehow lost? The answer lies not in a single magical ingredient, but in a brilliantly sophisticated recipe and a profound understanding of chemical processes. Modern Portland cement-based concrete, the kind we use for almost everything today, is fundamentally different. We primarily use a mix of limestone and clay, heated to high temperatures, which creates a brittle compound. When this concrete cracks, which it inevitably does, water seeps in, corroding the internal steel rebar and causing the entire structure to spoil and weaken from within. It's a slow but predictable race against time. The Romans, however, worked with a different philosophy. Their concrete was a mix of lime, volcanic ash known as pozzolana, and aggregates like chunks of rock and brick. The true masterstroke, particularly for structures exposed to the sea like the harbor at Caesarea, was the deliberate use of seawater in the mix. For centuries, modern scientists assumed this seawater was a mistake, a contaminant that would hasten decay. It was only through advanced analysis using tools like electron microscopes and X-ray microdiffraction that researchers uncovered the astonishing truth. When the Romans combined lime, volcanic ash, and seawater, they initiated a complex, long-term chemical reaction. The seawater instantly triggered a hot pozzolanic reaction, binding the mixture together. But the real magic happened over the ensuing centuries. Seawater slowly percolating through the concrete dissolves components of the volcanic ash and lime, allowing them to recrystallize into new minerals, most notably a rare plate-like mineral called aluminous tobamorite. This is the self-healing property of Roman concrete. Instead of water widening cracks and causing damage, the water actively facilitates a repair process. The formation of these interlocking crystalline structures actually fills in the micro-fissures that naturally develop, making the concrete progressively stronger and more resilient over time. The Romans had essentially invented a living material, one that could adapt to stress and heal its own wounds, a feature our own static concrete can only dream of replicating. This was not a happy accident. The sheer scale and consistency of Roman maritime construction, from massive breakwaters to sprawling harbor towns, proves this was a standardized, understood technological practice. The implications of this discovery are monumental for our own future. Today, concrete production is a massive contributor to global carbon emissions, accounting for roughly 8% of the world's total. Because Roman concrete uses less lime and doesn't require the extremely high heating temperatures of Portland cement, its revival could dramatically reduce that environmental footprint. Furthermore, imagine constructing seawalls, nuclear containment facilities, or critical dams with a material that grows stronger with exposure to the elements, rather than one that requires constant, expensive maintenance and eventual replacement. We are now, in the 21st century, actively trying to reverse engineer and replicate this 2,000-year-old technology to solve some of our most pressing modern challenges. The enduring strength of the Pantheon's dome is not merely a testament to Roman ambition. It is a silent, enduring lesson in sustainable engineering, a masterclass from the past that we are only now beginning to fully comprehend. Now, let us shift our focus from the grand scale of architecture to a small, unassuming clay pot that has ignited one of the most enduring and controversial debates in the history of archaeology. In the basement of the National Museum of Iraq in Baghdad sits a peculiar artifact discovered in 1936 just outside the city in a 2,000-year-old Parthian settlement. It consists of a simple 5-inch tall clay jar. Inside this jar, archaeologists found a rolled-up copper sheet forming a cylinder, and within that cylinder, an iron rod. The rod was held firmly in place at the neck of the jar by an asphalt plug, which acted as a stopper, sealing the contents and insulating the two metals from direct contact at the top. On the surface, it looks like a bizarre storage container, but when the German archaeologist Wilhelm Koenig first studied it, he proposed a theory so revolutionary it seemed to defy the entire timeline of electrical science. He suggested that if this jar were filled with an acidic liquid, something as common as vinegar or grape juice, it would cease to be a simple pot and would instead become something extraordinary, an ancient electric battery. The principle at play is the same one discovered by Alessandro Volta in the year 1800 when he created the first modern voltaic pile. This clay jar, now famously known as the Baghdad Battery, is a classic design for a galvanic cell. The acidic electrolyte, the vinegar, would react with the two different metals, the copper cylinder acting as the positive cathode and the iron rod as the negative anode. This chemical reaction would force electrons to flow from the iron to the copper through the electrolyte, creating a small but measurable electric potential difference or voltage between the two metal terminals. Experimental reconstructions have consistently proven this works, producing anywhere from half a volt to as much as 2 volts of electricity. While a single cell wouldn't power much, connecting several of these jars together in a series could theoretically produce a significant current. The immediate, tantalizing question is, what would an ancient civilization possibly need with an electric current 2 millennia before the light bulb was invented? This is where the debate fractures into 2 distinct camps, each with compelling arguments. The first and most captivating theory is that the Parthians or later Sasanians used these cells for electroplating, the process of using an electric current to bind a thin layer of a precious metal, like gold, onto the surface of a less valuable object such as silver or copper. There are ancient artifacts from the same region and period that show what appears to be remarkably fine and consistent gold plating, a result that some experts argue is difficult to achieve with mercury-based fire gilding alone, the method previously assumed to have been used. The idea is that artisans could have suspended a silver object in a solution of gold salts, connected it to the positive terminal of a battery, and used the electric current to attract and bond the gold particles evenly across the entire surface, creating a flawless, durable gilding. This would represent a technological leap so profound it feels almost anachronistic. The opposing view, held by many mainstream archaeologists, argues for a far more mundane explanation. They propose the jar was simply a secure storage container for sacred religious or magical scrolls, likely made of papyrus or parchment. The iron rod, in this interpretation, was just a convenient spindle around which a scroll could be rolled, and the entire apparatus was then sealed with asphalt to protect the delicate contents from moisture and insects. Skeptics point out that no wires or conductors have ever been found with these jars, nor have any electroplated objects been definitively linked to the batteries through chemical analysis. Furthermore, the asphalt seal is not completely airtight, which would cause a liquid electrolyte to evaporate over time, making it a rather impractical long-term power source. For this camp, the battery is a classic case of a modern interpretation being projected onto an ancient object, seeing advanced technology where there was only simple utility. The implications, however, if Koenig and his supporters are even partially correct, are staggering. It would mean that the fundamental principles of electrochemistry were not only understood, but were being practically applied in workshops nearly 2,000 years before they were formally rediscovered in Europe. This single, humble artifact challenges the linear narrative of scientific progress, suggesting that knowledge can appear, be used for a specific purpose, and then vanish from the historical record for centuries. It forces us to consider whether other, magical or unexplained feats from antiquity, from the eternal lamps described in some underground tombs to certain alchemical processes, might have had a basis in this lost electrical understanding. The Baghdad Battery, whether it was a sacred scroll case or the world's first electrochemical cell, remains a powerful symbol of the mystery that still shrouds the ancient world. A small, silent vessel holding not just clay and metal, but a profound and unresolved question about the true extent of our ancestors' ingenuity. Yet another technological marvel from the ancient world shifts our focus from quiet mystery to roaring, terrifying spectacle. Picture the scene. The year is 673, and a massive Arab fleet is advancing on the great city of Constantinople, the capital of the Byzantine Empire. The defenders' ships, massively outnumbered, sail out to meet the invaders. As the enemy vessels close in, something unbelievable happens. From the prows of the Byzantine dromons, bronze tubes project a stream of liquid fire that ignites as it flies through the air, striking the wooden warships. This is not ordinary fire. It clings to everything it touches. It burns with an intense heat even on the surface of the water, and frantic attempts to douse it with water only make the flames rage more violently. Panic and chaos engulf the Arab fleet as their ships are transformed into an inescapable inferno. This was the debut of Greek fire, a weapon so potent it became the ultimate naval deterrent for centuries, single-handedly preserving the Byzantine Empire from conquest and altering the course of history. The sheer terror of this weapon lay in its unique and nightmarish properties. Contemporary accounts describe it as a sticky, liquid substance, often launched via a pressurized siphon that functioned like a primitive flamethrower. The flames it produced were said to be accompanied by thunderous roars and copious smoke, creating a psychological impact as devastating as its physical destruction. Most critically, and this is what made it so revolutionary, it was inextinguishable by water. In fact, many historical sources suggest that water actually intensified the combustion. This single characteristic meant that the primary defense for any wooden navy, the sea itself, became useless. Fleets could be annihilated completely, with survivors reporting that the only escape was to leap into the sea and swim for their lives, leaving their ships and comrades to be consumed by the unstoppable blaze. The secret of Greek fire's composition was the Byzantine Empire's most closely guarded state secret, on par with the value of nuclear codes today. The knowledge was compartmentalized, reportedly known only to a select few individuals, perhaps even a single family. The formula was said to have been devised by a Syrian architect named Kallinikos, who fled to Constantinople and presented it to the emperor. The precise mixture was so critical to state security that emperors personally oversaw its production, and discussing its formula openly was considered an act of treason punishable by death. This extreme secrecy is the primary reason its exact recipe remains one of history's great unsolved mysteries. We can, however, make educated guesses based on its described behavior and the chemicals available at the time. Most experts agree it was almost certainly a crude oil-based concoction, likely incorporating naphtha from natural petroleum seeps around the Black Sea. The key to its pyrotechnic prowess, however, was probably the addition of quicklime, which ignites upon contact with water, and perhaps other secret ingredients like resin or sulfur to increase its adhesive quality and burning temperature. Some theories even suggest the mixture contained potassium nitrate, a key component of gunpowder, allowing it to ignite spontaneously upon launch. Whatever the combination, it represented a staggering achievement in applied chemistry. The legacy of this ancient superweapon is a powerful lesson in how technology can be both created and lost. For over 7 centuries, Greek fire ensured Byzantine naval dominance, repeatedly saving Constantinople from sieges and securing its status as the bulwark of Christendom. Yet the very paranoia that protected the secret also contained the seeds of its demise. By restricting the knowledge to such a small, exclusive circle, the Byzantines created a single point of catastrophic failure. It is believed that by the time the empire finally fell to the Ottoman Turks in 1453, the knowledge of how to manufacture the true, pressurized siphon version of Greek fire had already been lost for generations. The formula died with its last custodians. We can attempt to recreate approximations in modern labs, but the original, battlefield-tested substance, perfected through generations of use, is gone forever. It stands as a potent symbol of the fragility of human knowledge, a brilliant flash of chemical engineering that illuminated the ancient world before being swallowed again by the shadows of time. Now we turn from the fiery engines of war to the silent, profound mastery of the open sea. Imagine setting sail across the largest ocean on the planet, an expanse of water so vast it covers nearly a third of the Earth's surface, with no compass, no sextant, and no charts. For most of human history, such a voyage would have been considered a death sentence, a one-way trip into the terrifying unknown. Yet, centuries before European explorers like Magellan and Cook even dreamed of their journeys, a civilization of incredible mariners was not just surviving these voyages. They were systematically and deliberately discovering and settling virtually every habitable island across this immense aquatic wilderness. The Polynesian expansion across the Pacific Ocean stands as one of humanity's most breathtaking and audacious achievements, a testament to a form of technology that was not built from gears or concrete, but from a deep, intimate, and sophisticated reading of the natural world. At the heart of this feat were the vessels themselves, the double-hulled voyaging canoes or waka awayua. These were not primitive rafts or simple dugouts. Picture 2 large, sleek hulls, each meticulously carved from massive tree trunks, connected by a sturdy platform that could carry dozens of people, along with their plants, animals, and everything needed to establish a new colony. This twin-hull design provided incredible stability in the open ocean, allowing the canoe to ride massive swells without capsizing. A single large, triangular crab claw sail made from woven pandanus leaves could harness the wind with remarkable efficiency, propelling these craft across thousands of miles of ocean. This was a vehicle purpose-built for exploration and colonization on a grand scale, a maritime technology perfectly adapted to its environment. But the true genius of Polynesian navigation, known as wayfinding, lay not in the canoe itself, but in the mind of the navigator. These master voyagers, who spent years in rigorous training, committed the entire Pacific seascape to memory. They were living libraries of the ocean, using a complex system of environmental clues to maintain their course. The star compass was their foundational tool. They had memorized the rising and setting points of hundreds of stars, creating a mental star map where specific celestial bodies acted as directional beacons. They knew that the star Sirius, for example, rose in a certain position to guide them toward the Marquesas, while the Southern Cross pointed the way south. They didn't just follow one star, they would track a succession of stars throughout the night, constantly updating their position with an almost subconscious precision. During the day, when the stars were invisible, they turned their attention to the sun and the moon, but more importantly, to the ocean itself. They became expert readers of ocean swells. The Pacific is crisscrossed by large, consistent swell patterns generated by distant weather systems. A trained navigator could lie down in the canoe and, by feeling the subtle rise and fall and the direction of the rocking motion, determine the direction of a primary swell. Any disruption to this rhythm, a new swell intersecting from a different angle, signaled a change in weather or the proximity of an unseen island. The behavior of clouds offered another critical clue. A stationary, puffy cloud over a distant horizon often forms around the warm, rising air of an island, even if the land itself is still far below the horizon. The color of the clouds could also change, reflecting the green lagoons or white sand of an island dozens of miles away. Life itself became their guide. The navigators held an encyclopedic knowledge of seabird behavior. Certain species, like the tern or the booby, fly out from land to fish in the morning and return to their nests at dusk. By observing the direction of these flights, a navigator could find land that was over 100 miles distant. They even watched for drifting vegetation, the types of seaweed in the water, and the specific kinds of land-nesting birds that would gather around the canoe as they drew closer to an island. This was a holistic science, a system where every element of the sky, sea, and its creatures was a piece of a navigational puzzle. The scale of this accomplishment is almost incomprehensible. Starting from a homeland in the Western Pacific, now thought to be the islands of Tonga and Samoa, these voyagers embarked on deliberate journeys of discovery. They sailed east against the prevailing winds to reach the Marquesas and the Society Islands, a strategy that ensured a safer, downwind return voyage. From there, they launched into the most incredible legs of their expansion, north to the isolated archipelago of Hawaii, a journey of over 2,500 miles of open ocean, and southeast to Rapa Nui or Easter Island, one of the most remote inhabited places on Earth. The settlement of Aotearoa or New Zealand represented a voyage into colder, temperate latitudes that required adapting their wayfinding techniques to a completely new set of stars and ocean conditions. This was not a case of helpless sailors being blown off course and stumbling upon islands by accident. These were intentional, round-trip voyages of exploration and colonization, planned and executed with a sophistication that European navigators, utterly dependent on their instruments, could not initially comprehend. When Captain James Cook arrived in Tahiti in the 1760s, he was astounded to find that the Tahitian priest and navigator Tupaia could not only name over 130 islands, but could also point out their precise directions and describe their people, drawing a mental map of the Pacific that was far more complete than any chart in Cook's possession. The Polynesian voyagers had, without writing, without metal, and without any instruments we would recognize, mastered the greatest ocean on the planet through intellect, courage, and a profound connection to the natural world that remains one of history's most stunning examples of human ingenuity. But our journey through the corridors of ancient genius does not end with the mastery of fire or sea. Let us now travel to the Qut complex in Delhi, India, where a different kind of marvel stands in plain sight, one that defies a fundamental law of nature that plagues nearly all of our modern steel structures: rust. Here, soaring over 23 feet into the air and weighing more than 6 tons, is the Iron Pillar of Delhi. Forged in the 4th or 5th century AD, this immense iron column has spent over 1,600 years exposed to the sweltering heat, torrential monsoon rains, and polluted air of one of the world's most demanding urban environments. And yet, despite all of this, its surface remains remarkably smooth and free of the corrosive cancer that would have consumed a modern steel beam in a matter of decades. It is a silent, stoic testament to a lost art of metallurgy, so advanced that it continues to baffle and inspire scientists in the 21st century. The first clue to its mystery lies in its sheer existence. Creating such a massive, singular piece of wrought iron in ancient times was a monumental feat in itself. Modern historians and metallurgists believe it was constructed using a method akin to sophisticated blacksmithing on a colossal scale. Imagine teams of artisans heating small pieces of iron-rich sponge iron in a charcoal-fired furnace. They would then repeatedly hammer-weld these white-hot pieces together on an anvil, folding and forging them into a single, solid mass. To create the pillar, they likely built it up in sections, meticulously forged, welding one disc of iron on top of another, like stacking and fusing massive metallic pancakes until the entire column was formed. The very fact that it remains a single, cohesive unit after 16 centuries, without cracking or failing at the weld points, speaks to an almost supernatural level of skill and quality control practiced by these ancient smiths. But the real magic, the property that truly sets it apart, is its legendary resistance to corrosion. For a long time, a popular myth suggested that the pillar was made from a special, non-rusting cosmic metal. The scientific truth, while less magical, is in many ways even more impressive. The answer lies not in the absence of impurities, but in the presence of a very specific and deliberately engineered one. The iron of the pillar is, in fact, remarkably pure for its time, with a high phosphorus content and a very low sulfur and manganese content. This specific chemical composition is the key to its longevity. While modern steel production deliberately removes phosphorus because it can make steel brittle at low temperatures, the ancient Indian metalworkers had no such process. They were working with the iron ores available to them, which in this region happened to be rich in phosphorus. This apparent impurity turned out to be the pillar's saving grace. During the forging process, the high phosphorus content combined with the iron and oxygen led to the formation of a unique, thin, and invisible protective layer on the surface of the metal known as a passive film. This film is a complex blend of iron, oxygen, and hydrogen, with phosphorus playing a critical role in its formation and stability. It acts as a barrier, a kind of crystalline skin that prevents oxygen and moisture from penetrating deeper into the metal to form the destructive red oxides we know as rust. It's a self-repairing shield. Minor scratches or abrasions on the surface are naturally healed as the protective layer reforms, a process catalyzed by the high phosphorus content in the metal beneath. In essence, the ancient blacksmiths, without knowing the atomic-level chemistry, had accidentally invented a form of permanent, self-regenerating anti-corrosion coating, a technology we strive to replicate with modern paints, galvanization, and alloying. This was not a one-off, lucky accident. The consistent presence of high phosphorus iron in other artifacts from the same period suggests this was a known and replicated technique within the advanced ironworking traditions of ancient India. They had perfected a recipe and a process that yielded a material with incredible durability. Today, the iron pillar is a living laboratory for materials scientists and corrosion engineers from around the globe. They study it using the most advanced tools available, scanning electron microscopes, X-ray diffraction, and electrochemical analysis, all in an effort to fully decode the secret of its passive layer. The goal is to apply these ancient principles to modern challenges, such as developing new, longer-lasting alloys for bridges, ship hulls, and reinforced concrete in coastal areas, where corrosion costs nations billions of dollars annually in maintenance and replacement. The pillar stands not just as a monument to a forgotten king, but as a timeless teacher, its silent, rustless surface offering a masterclass in material science that we are still struggling to graduate from. While we stand in awe of rust-resistant pillars and fiery naval weapons, true advancement is often measured by something far more fundamental to human dignity and public health, the simple act of disposing of waste. For this, we must travel back over 4,000 years to the banks of the Indus River, to a civilization that understood the connection between cleanliness and civic order in a way that would not be seen again for millennia. The cities of Mohenjo-Daro and Harappa, flourishing between 2500 and 1900 BC, were marvels of urban design built with a foresight that is almost unnerving. Unlike the more familiar, monument-focused civilizations of Egypt and Mesopotamia, the Indus Valley people invested their genius not in pyramids for the dead, but in creating a livable, healthy environment for the living. At the heart of this achievement was the world's first comprehensive, city-wide sanitation system, a network of such sophistication that it puts many later historical capitals to shame. Walking through the baked brick streets of Mohenjo-Daro, you would have noticed a remarkable sense of order. The main streets were laid out in a precise grid pattern, and running alongside them, often down the very center, was a meticulously engineered system of drainage. This was not just a few open gutters. These were carefully constructed covered drains built from uniformly sized, kiln-fired bricks and sealed with a tight, waterproof gypsum mortar. From these main arterial drains, smaller channels branched off, connecting directly to the individual homes that line the streets. The system was designed with a subtle, consistent slope, a gentle gradient that ensured waste and water would flow steadily away from the residential areas and toward the outskirts of the city. This was not a haphazard addition. It was an integral, pre-planned feature of the city's very foundation. The builders even incorporated ingenious features like curved corners at the junctions of drains to maintain a smooth flow and prevent clogs, and periodic sump pits or cesspits where solid waste could settle out before the liquid continued on its way, a primitive but effective form of sewage treatment. The commitment to hygiene extended right into the private homes of the citizens. A significant number of houses, particularly those of the more affluent, contained dedicated bathrooms. These were not just crude corners of a room. They were carefully constructed spaces with floors that sloped towards a corner drain. Wastewater from these bathrooms, along with water from household kitchens, was channeled through terracotta pipes or brick-lined chutes embedded in the walls, which then emptied directly into the covered street drains below. In some of the larger homes, archaeologists have even identified what appear to be distinct latrine areas, with seated toilets that emptied into these same waste chutes. This level of private sanitation, with a direct connection to a public sewer system, represents a concept of public health that was staggeringly ahead of its time. It reveals a society-wide understanding that community wellness depended on managing waste effectively at the source, a philosophy that valued collective well-being through infrastructural investment. The starkness of their achievement becomes truly breathtaking when we contrast it with the sanitary conditions in Europe thousands of years later. Fast forward to the Middle Ages or even to the bustling, enlightened London of the 17th and 18th centuries. There, the concept of a public sewer system was virtually non-existent. Waste was simply tossed from windows into the streets with a shouted warning, creating a foul, disease-ridden environment. Rivers like the Thames served as open sewers, choked with human and industrial effluent, a situation that famously led to the Great Stink of 1858, when the smell from the river was so overpowering it forced Parliament to suspend its session. Diseases like cholera and typhoid, spread by contaminated water and poor sanitation, were rampant and regularly swept through populations, killing tens of thousands. The very idea of a covered, city-wide drainage network connecting private homes would have been seen as an impossible fantasy. This dramatic divergence forces us to ask a profound question: how did this knowledge become lost? The answer is as complex as the fall of the Indus Valley civilization itself. Around 1900 BC, this remarkably organized society began to decline, likely due to a combination of factors including climate change, the shifting course of the Indus River, and the possible incursion of new peoples. As their centralized authority and urban cohesion broke down, the meticulous maintenance required for their sophisticated infrastructure would have become impossible. The knowledge of how to build and manage such systems was likely held by a specialized class of engineers and planners. When the cities were gradually abandoned, that specialized knowledge, not being written down in a decipherable script, simply faded from human memory. The technology wasn't improved upon or exported. It was buried quite literally under the silt of the Indus Plains for over 3,000 years. The West would have to painfully and slowly relearn the principles of public sanitation through centuries of plagues and public health crises, a lesson the ancient inhabitants of Mohenjo-Daro and Harappa had mastered and implemented as a cornerstone of their urban civilization. Their silent, buried cities stand as a haunting reminder that progress is not a guaranteed forward march, and that a society's greatest legacy can sometimes be the invisible infrastructure that keeps its people healthy and safe. But long before the iron pillar defied corrosion or the sewers of Mohenjo-Daro channeled waste, another civilization was polishing a small piece of crystal to a degree of perfection that would ignite a modern scientific debate. In the ruins of the ancient Assyrian palace of Nimrud, within a room that dated to around 750 BC, archaeologists uncovered a small, oval-shaped piece of rock crystal, roughly ground and slightly cloudy with age. At first glance, it appears unremarkable, a discarded piece of jewelry or a decorative inlay, but when you hold it to the light, its true nature is revealed. This is the Nimrud lens, a 3,000-year-old object that has been meticulously shaped into a convex form, and it is one of the most tantalizing and disputed artifacts in the entire history of technology. The fundamental question surrounding this tiny piece of crystal is deceptively simple. What was its purpose? The most straightforward explanation is that it was a magnifying glass. With a focal length of about 4 inches, the lens is fully capable of enlarging small objects. An artisan or scribe could have used it for tasks requiring fine detail, such as intricate engraving on seals or jewelry, or for carefully forming the tiny, precise cuneiform characters on clay tablets. This would have given its user a significant advantage, allowing for a level of miniature work that would otherwise be incredibly straining on the eyes. As an extension of this idea, the lens could have also served as a burning glass. Held at the correct angle to the sun, it concentrates sunlight into a tiny, intensely hot spot, capable of igniting tinder and starting a fire. This would have been a valuable tool, a precursor to the modern lens that could summon a flame seemingly from nothing, a piece of practical magic in the ancient world. However, the most radical and captivating theory, first proposed by the Italian astronomer Giovanni Pettinato, is that the Nimrud lens was not a tool for craftsmen or fire starting, but an optical component in an ancient telescope. Pettinato suggested that the Assyrians, who were renowned for their detailed and accurate astronomical records, might have used such a lens as an eyepiece in a simple, tubeless telescopic device. This would have allowed them to observe celestial bodies with a clarity far beyond the naked eye, potentially explaining how they were able to make such precise notations of planetary movements and phenomena like the phases of Venus. The implications of this theory are staggering. It would mean that the basic principles of telescopic observation, a technology we credit to Dutch spectacle makers in the early 17th century, were not only understood but actively employed a full 2 millennia earlier. This would completely rewrite the history of astronomy, suggesting that the detailed knowledge of the heavens displayed by the Assyrians was not just the product of patient, unaided observation, but was aided by optical technology. Of course, this revolutionary idea is met with considerable skepticism from many mainstream archaeologists. The primary counter-argument is one of context. The lens was found not in an observatory or a scientist's workshop, but in a storage room alongside a hoard of beautiful, polished crystals that were almost certainly intended for decorative inlay in ivory furniture. To the skeptics, the Nimrud lens is just that, a beautifully polished piece of crystal for decoration, and its optical properties are merely a fortunate or unfortunate accident of its shape. They argue that if the Assyrians truly possessed the knowledge to create telescopic lenses, we would have found more of them, or at least some other corroborating evidence of their use in astronomical contexts, such as written descriptions of magnified stars or the planets. The fact that we have only one and its optical quality, while good, is not perfect, suggests to them that it was an experimental piece or a decorative object that simply can function as a lens, not that it was designed specifically for that purpose. Yet, the existence of the lens alone, regardless of its intended use, forces us to confront a profound possibility. The mere act of grinding and polishing a piece of rock crystal into a convex form demonstrates a sophisticated, hands-on understanding of how light behaves when passing through a transparent medium. Whether it was an artisan seeking to magnify his work, a priest using it to focus sunlight for a ritual fire, or an astronomer peering at the stars, the individual who created this object understood the fundamental principle of refraction. This knowledge represents a pocket of optical science that flickered into existence long before the Greek philosophers began to formally theorize about light. The Nimrod lens is a silent, crystalline sentinel from a time of unrecorded genius, a physical whisper that the path of discovery is not a straight line, but one dotted with brilliant, isolated flashes of understanding that were later forgotten, waiting patiently in the dust for us to find them and wonder. Our next leap into the ancient world takes us to a time when the very ground beneath one's feet could betray a city without warning. In the year 132 AD, during the Han Dynasty, the brilliant court astronomer and mathematician Zhang Heng presented the emperor with a device that seemed to border on the magical, the Hufeng Didongyi, or the instrument for inquiring into the wind and the motion of the earth. To the modern eye, it was a breathtaking work of art and science, a large bronze urn, intricately decorated and encircled by 8 dragons, each poised head down with a bronze ball held delicately in its jaws. Below each dragon sat a corresponding bronze frog, its mouth gaping open, ready to receive the ball. This was the world's first seismoscope, and its purpose was not to predict earthquakes, but to detect their occurrence from hundreds of miles away and, most astonishingly, to indicate the direction from which the tremors had come. The sheer brilliance of Zhang Heng's device lay in its hidden internal mechanism. While the exact details have been lost to time, the most widely accepted theory proposed by modern seismologists suggests an astonishingly elegant system. Inside the ornate bronze vessel, they believe, hung a heavy inverted pendulum suspended from the top. This pendulum was free to swing in any direction, acting as the sensitive inertial mass. Arranged around the base of this pendulum were a series of levers or geared mechanisms, each one connected to a dragon's head on the corresponding side of the vessel. When seismic waves, the primary waves that travel fastest from an epicenter, reached the device, they would cause the pendulum to swing. It wouldn't just jiggle randomly, it would swing with a distinct preference toward the direction of the earthquake's origin. This motion would then trigger only one of the internal levers, the one aligned with the direction of the force. That lever would act like a catapult release, propelling the dragon's head on that specific side to open its jaws and drop the bronze ball with a resonant clang directly into the mouth of the waiting frog below. The historical record provides a stunning validation of the device's accuracy. According to ancient chronicles, on one occasion a single ball was released from a dragon facing west. The event was met with skepticism at the imperial court in Luoyang, as no tremors had been felt locally. Several days later, a messenger arrived from a commandery hundreds of miles to the west, reporting that a major earthquake had indeed struck there on the very day, and at the very hour the dragon had dropped its ball. This account demonstrates a profound understanding of geophysics that feels centuries ahead of its time. Zhang Heng's device wasn't just detecting local shaking, it was sensitive enough to pick up the subtle, long-distance vibrations of the Earth's primary waves, which are often imperceptible to humans, and use them to pinpoint a direction. This meant that the Han court could receive confirmation of a distant disaster days before messengers could arrive, allowing for a swifter and more organized relief response. It transformed earthquake reporting from a matter of hearsay into a matter of mechanical fact. What makes this invention so revolutionary is that it represents a fundamental shift in how humanity could interact with invisible natural forces. Zhang Heng had essentially created a mechanical sense organ for the entire empire, a device that could feel what human beings could not. He understood that the earth communicates through vibrations, and he devised a way to translate that vibrational language into a clear, unambiguous signal. The loss of the specific internal design is one of history's great tragedies for engineering. Modern attempts to reconstruct it have shown that the mechanism likely had to be incredibly sensitive yet stable enough to avoid false alarms from wind or nearby traffic, a balancing act that speaks to a highly refined level of technical skill. This was not a philosophical toy. It was a precision instrument for imperial governance and public safety, a testament to a mind that saw the world as a system of interconnected physical forces and dared to build a machine to listen to its whispers. While ancient astronomers charted the stars and master smiths forged rust-resistant iron, our next discovery hurtles us into a mystery that seems to defy the very timeline of human civilization. It's a story that begins not in a royal tomb or an ancient city, but in the rocky, arid landscape of California's Coso Mountains. In February 1961, a small group of rock and gem hunters were searching for interesting specimens. They were cracking open what appeared to be a solid, round geode, expecting to find the beautiful, crystalline interior typical of such formations. Instead, their chisel revealed something that made no sense whatsoever. Embedded firmly within the stone was a manufactured object, a cylinder of hard, white ceramic, surrounded by a rusty metal sheath, and at its core, a 2 mm thick magnetic metal rod. To anyone with even a passing knowledge of mechanics, it was unmistakable. This was a spark plug. The immediate, staggering problem was the age of the geode itself. The rock hunters took their bizarre find to a geologist who examined the outer crust of the nodule. Based on its composition and the standard rates of mineral accumulation, he estimated it had taken a minimum of 500,000 years for the rock to form. This single assessment catapulted the object from a curious oddity into a full-blown historical cataclysm. Here was a piece of 20th century technology, seemingly encased within a stone that predated not just modern industry, but our own species, Homo sapiens. The so-called Coso artifact instantly became one of the world's most famous OOP arts, an out-of-place artifact, an object that appears far too advanced for the stratum in which it is found, challenging conventional historical and scientific timelines. To get a clearer picture of what they were dealing with, the discoverers had the entire nodule X-rayed. The images only deepened the enigma. They confirmed the object's complex internal structure, revealing what looked like a hexagonal nut or collar at one end, a broken-off metal stem, and the distinct central shaft. It wasn't just a lump of metal that resembled a spark plug. Its internal anatomy was mechanically precise. For proponents of ancient astronaut theories or lost advanced civilizations, this was compelling evidence. They argued that the Coso artifact was a genuine relic from a prehistoric technological society, perhaps from Atlantis or even visitors from another world, whose advanced tools were lost and fossilized in a distant, forgotten age. The 500,000-year date seemed to be an unassailable geological fact, locking this impossible piece of machinery in stone long before humans were supposed to have mastered fire, let less metallurgy. However, science thrives on investigation, and a more plausible, though still fascinating, explanation eventually emerged. In the 1990s, a researcher named Pierre Stromerck, along with the electrical engineer Paul Willis, decided to re-examine the evidence with a more critical eye. They started with the object itself, noting its striking resemblance to a specific type of early 20th century spark plug, particularly those from the 1920s made by brands like Champion. This was a crucial lead. The next step was to challenge the 500,000-year age estimate. They argued that the object wasn't encased in a true geode, which forms from volcanic activity, but in a concretion, a hard, round nodule that forms much more quickly when mineral cement precipitates and accumulates around a central nucleus. In this case, the nucleus was the spark plug itself. The theory they developed presents a scenario that is almost as remarkable as the ancient civilization idea. They proposed that the spark plug was lost or discarded in the early 1920s, perhaps from a mining vehicle or a Model T Ford in the then busy Coso Mountain region. It fell into a moist, mineral-rich environment, likely a mudflat or a shallow body of water. The iron components of the plug began to rust, and this rust, mixed with the local clay and dissolved minerals like dolomite and granite, began to form a hard, shell-like concretion around the object. The unique chemical conditions could have accelerated this process dramatically, creating a rock-hard casing in a matter of decades, not millennia. This phenomenon, known as accelerated concretion formation, is rare but not unheard of. It's the same process that can entomb modern objects like tin cans and bottles in a surprisingly short time under the right geochemical circumstances. The true puzzle of the Coso artifact, then, shifts from a question of history to a question of geology. It becomes a case study in how quickly nature can fossilize the present, creating an illusion of immense antiquity. While the initial 500,000-year estimate captured the public imagination, the revised explanation reveals a different kind of wonder, the incredible and sometimes deceptive speed of natural processes. The artifact is no longer proof of a lost civilization, but rather a testament to how a combination of mundane human litter and unusual environmental conditions can conspire to create a perfect, perplexing mystery. It serves as a powerful reminder that when we stumble upon the impossible, we must first rule out the improbable workings of the natural world, a world capable of performing its own sleight of hand, turning a simple piece of junk into a riddle that echoes across the centuries. From the perplexing Coso artifact, we now journey to a place where the evidence of incredible skill is not hidden inside a stone, but displayed on a monumental scale, carved directly into some of the hardest rock on Earth. For this, we travel to the sands of Saqqara, Egypt, to a subterranean wonder known as the Serapeum. This vast, labyrinthine network of tunnels was the final resting place for the sacred Apis bulls, venerated by the ancient Egyptians as incarnations of the god Ptah. While the concept is fascinating in itself, it is the method of entombment that plunges us into one of Egyptology's most enduring technical mysteries. Here, lining the dark, echoing corridors, are 24 massive sarcophagi, each one carved from a single, solid block of either granite or diorite. These are not rough-hewn stone boxes. They are masterpieces of precision engineering that defy our standard understanding of the tools available to the New Kingdom Egyptians over 3,000 years ago. The sheer physical challenge of working with these materials is the first hurdle to comprehend. Granite and diorite are phenomenally hard stones, ranking high on the Mohs scale of mineral hardness. To put this in perspective, the copper chisels and stone hammers that mainstream Egyptology tells us were the primary tools of the ancient stonemasons have a hardness of around 3 or 4. Granite has a hardness of 6 to 7. It is a fundamental principle of material science that to cut or abrade a substance, your tool must be harder than the material you're working on. A copper chisel struck against granite would barely scratch the surface. It would simply dull, bend, and become useless long before it could shape a single corner. The idea of using such soft tools to create the objects in the Serapeum is akin to trying to carve a block of steel using a stick of butter. It's a physical impossibility. Yet, the evidence of their work is undeniable and breathtaking. Each of these sarcophagi is colossal, weighing in at an estimated 70 to 100 tons. Their surfaces are not just roughly flat, they are polished to an almost machine-like perfection, with a flatness and uniformity that is consistent across the entire massive expanse. The corners where these immense surfaces meet are not just approximately square, they are razor-sharp, precise 90-degree angles that run perfectly straight from top to bottom. The inside surfaces of the boxes mirror this precision, with the interior corners being just as sharp and clean as the exterior ones. Perhaps most tellingly, the lids, which weigh many tons themselves, fit into their slots with such an exacting tolerance that you cannot slide a piece of paper between the lid and the rim of the box. This is a level of precision that speaks of a manufacturing process far removed from the percussive pounding of stone hammers. So, if not copper chisels, how was this achieved? This is the core of a debate that has raged for decades, dividing traditional Egyptologists from engineers and alternative historians. The conventional explanation involves a process of relentless pounding using balls of dolerite, a stone harder than granite. The theory is that workers would pummel the surface of the granite with these dolerite pounders, gradually pulverizing the crystalline structure grain by grain. While this method could, in theory, eventually shape a block, it completely fails to explain the precision. You cannot achieve optically flat surfaces, perfectly straight edges, and impossibly tight tolerances through brute force pounding. That process is inherently imprecise and would leave a fractured, uneven surface, not the glass-smooth finish we observe. It also offers no explanation for how they managed to hollow out the interior of these solid blocks with such perfect, sharp internal corners. This gap in the conventional narrative has led to a compelling and controversial alternative theory that the ancient Egyptians possessed and utilized advanced machining techniques, knowledge of which was later lost. Engineers who examine the sarcophagi point to features that are hallmarks of modern manufacturing. The flatness of the surfaces suggests the use of some form of milling machine capable of making precise, linear cuts across a wide area. The sharp, unbroken internal and external corners could indicate the use of a tool that rotated, like a drill bit or an end mill, which could cleanly remove material from a corner without fracturing it. The polish on the stone is so consistent that it suggests the use of powered polishing tools, not just hand sanding with quartz sand. The most radical suggestion involves the type of cutting tool that would have been required. To efficiently cut granite, you need a material with a hardness of 8 or above. This leads to the fascinating possibility that the Egyptians had access to and knew how to use diamonds. Diamond is the hardest natural substance known, with a hardness of 10. A diamond-tipped saw or drill, perhaps embedded in a copper or bronze matrix, would have been more than capable of slicing through granite with relative ease. We know that the Egyptians were familiar with corundum, the family of minerals that includes emery and sapphire, which has a hardness of 9. It is not a huge leap to suggest they may have discovered and utilized diamond as an abrasive. There is even a theory that they could have created a form of tubular drill, using a copper tube with diamond or corundum grit and a loose abrasive slurry to core out the interiors of vessels and sarcophagi. The spiral grooves sometimes found inside drilled granite artifacts lend strong credence to this idea, as they match exactly the marks left by a tubular drill under a constant feed pressure. The debate over the Serapeum sarcophagi is more than an academic squabble. It strikes at the heart of how we view technological progress. The conventional view demands that we accept that a civilization we believe had only simple bronze and stone tools achieved a level of precision that would be challenging even with today's computer-controlled machinery, and they did it on a colossal scale. The alternative view proposes that our historical timeline is incomplete, that pockets of highly advanced technical knowledge existed in the ancient world, specialized for specific tasks like stoneworking, and that this knowledge was not widespread and was eventually lost. Whether through the use of diamond-tipped tools, powerful and precise mechanical saws, or a lost technique we have yet to imagine, the granite boxes of the Serapeum stand as a silent, immovable testament to a skill that we can barely replicate today, a permanent question mark carved in stone that challenges us to reconsider what we think we know about our own past. Now let's move from the mysteries of stone to the enigma of a chart that seems to defy the very history of exploration. In the year 1929, inside the dusty archives of Istanbul's Topkapi Palace, a German theologian named Gustav Adolf Diesmann made a discovery that would ignite a firestorm of controversy lasting to this very day. He was cataloguing the palace's vast manuscript collection when he stumbled upon a forgotten world map, drawn on gazelle skin parchment and dated to the year 1513. Its creator was the Ottoman admiral and cartographer Piri Reis, who noted in the margins that he had compiled it from numerous source maps, including some that dated back to the time of Alexander the Great. At first glance, the surviving fragment was remarkable enough, showing the western coasts of Africa and Europe and the eastern shores of South America with surprising accuracy. But it was the lower portion of the map, a strangely shaped landmass curling around the bottom of the Atlantic, that would become the focus of an extraordinary claim. Several researchers, most notably Professor Charles Hapgood in the 1960s, proposed a breathtaking theory. This southern land was not a misplaced Patagonia or a mythical continent, but a stunningly accurate depiction of the coastline of Queen Maud Land in Antarctica, and most shockingly, it appeared to show the continent as it exists beneath its mile-thick ice cap. The core of this audacious argument rests on two startling observations. First, the map's rendering of the South American coastline is unnervingly precise for 1513. It correctly shows the bulge of Brazil and includes major rivers like the Amazon and the Paraná, details that European maps of the era typically got wrong or omitted entirely. More incredibly, it seems to depict the Andean mountain range running along the western edge of the continent, a geographic feature that was virtually unknown to European cartographers at the time. Second, and far more controversially, is the interpretation of the mysterious southern continent. Hapgood, working with cartographers, argued that when you account for the map's unique grid system, a modified Portolan chart that doesn't use the familiar Mercator projection, the landmass aligns almost perfectly with subglacial scans of the Antarctic coastline. Modern surveys using seismic and radar technology have mapped the true bedrock of Antarctica, revealing a jagged, complex topography buried under eons of ice. The Piri Reis map, its proponents claim, shows this very coastline with its fjords, inlets, and mountain ranges, as it would have appeared during a period of glacial retreat, a time when it could have been charted by human hand. The logical and world-shaking conclusion is that the map must be based on far older source maps, drawn by an advanced seafaring civilization that explored the planet when Antarctica was at least partially ice-free, a condition that last existed millions of years ago. Of course, such a radical theory invites intense and well-founded skepticism. Mainstream historians and cartographers offer a series of powerful counterarguments that seek to ground the map in its historical context rather than in a lost prehistoric age. The first and most significant rebuttal concerns the identity of the southern landmass. Skeptics argue it is far more likely a composite, speculative depiction of a terra australis incognita, the legendary, unknown southern land that had been a fixture on maps since the time of Ptolemy. Cartographers of the era, including Piri Reis, often filled blank spaces on their charts with hypothetical continents based on travelers' tales, classical geography, and pure conjecture. The map's own inscriptions lend credence to this. Piri Reis writes that the coastlines were drawn from maps captured from Spanish and Portuguese sailors, and he describes the region as a warm land full of large snakes and strange beasts, a description that fits the Amazon basin far better than the frozen wastes of Antarctica. Furthermore, the accuracy of the South American coast, while impressive, is not supernatural. Portuguese explorers had been charting Brazil for over a decade by 1513, and it is entirely plausible that Piri Reis, a well-connected admiral and collector of nautical intelligence, had gained access to these highly prized state-secret Portuguese charts. The most decisive blow to the ancient civilization theory, however, comes from the geological timeline itself. For Antarctica to be ice-free and navigable, it would need to be in a period of significant global warming. The last time the Queen Maud Land coastline was largely free of ice was not thousands, but millions of years ago during the Neogen period. For a human civilization to have mapped it, our entire understanding of human evolution would need to be rewritten. There is simply no archaeological evidence whatsoever for a global, seafaring culture capable of such feats millions of years before the rise of Homo sapiens. The technological and logistical leap required building ships capable of surviving southern ocean storms, developing the cartographic skills to produce accurate maps, and sustaining a transoceanic civilization places this theory firmly in the realm of fascinating speculation rather than established history. So where does this leave the genuine mystery of the Piri Reis map? The map's true wonder may not lie in a fictionalized prehistoric past, but in the very real, sophisticated exchange of knowledge that was occurring in the early 16th century. Piri Reis was not an isolated figure. He was part of the Ottoman Empire, a superpower that sat at the crossroads of the world, with access to Arabic, European, and possibly even Asian geographical knowledge. His achievement was one of synthesis. He was a brilliant compiler, a cartographic scholar who brought together disparate sources, some accurate, some fanciful, to create a unified vision of the world as it was understood by the most knowledgeable sailors and explorers of his day. The map is a tangible artifact of a world on the cusp of global awareness, a patchwork of hard-won empirical data and enduring mythological tradition. It reminds us that the process of discovery is messy, and that even the most accurate maps can contain layers of speculation and inherited error. The Piri Reis map endures not as proof of ancient astronauts or lost civilizations, but as a magnificent and complex puzzle from the age of exploration, a testament to the enduring human desire to chart the unknown, using every piece of information available, no matter how mysterious its origin. From the grand enigmas of global cartography, we now journey deep into the heart of the Mesoamerican jungle, to a civilization that peered into the cosmos and perceived time itself as a vast, interlocking machine. The Maya gazed at the heavens not merely with wonder, but with an analytical rigor so profound that their calculations, carved into stone stelae over 1,000 years ago, continue to astound modern astronomers. At the core of their intellectual achievement was a concept of time that stands in stark contrast to our own linear perspective. For the Maya, time was not a straight arrow flying from a distant past toward an unknown future. Instead, it was a series of grand, repeating cycles, wheels within wheels, each with its own spiritual character and influence on the earthly realm. This world, you demanded a level of precision we typically associate with computers, and they achieved it through a mathematical and observational genius that was, for its time, virtually unparalleled. The cornerstone of their temporal architecture was the long count calendar, a system designed to measure vast epochs. Think of it as a cosmic odometer, counting the days from a mythical starting point that our calendar places in August of 3114 BC. This count was expressed not in a simple decimal system, but in a modified base 20 or vigesimal system. They used a series of ascending units, the kin 1 day, the yuanal 20 days, the ton 360 days, the katon 7,200 days or about 20 years, and the bakton 144,000 days or about 394 years. A full cycle of 13 baktons, known as a great cycle, spans over 5,125 years. The conclusion of one such cycle in the year 2012 sparked a global frenzy of speculation about the end of the world, a notion that completely misunderstood the Mayas' cyclical philosophy. For them, it was never an end but a turning, a moment of profound renewal and the beginning of the next great revolution in the cosmic order. The true marvel is not the pop culture myth, but the sheer intellectual ambition to conceive of and track time on such a monumental scale. To power this grand calendar, the Maya needed to measure the fundamental rhythms of the solar system with extraordinary accuracy. Their calculation of the solar year stands as a testament to their patience and skill. Through generations of meticulous observation, likely using artificial horizons and carefully aligned temple doorways to track the sun's journey, they determined the length of the year to be 365.2420 days. Our modern Gregorian calendar, perfected centuries later, uses a value of 365.2425 days. The difference is a mere 0.00005 days per year, an error margin so minuscule it amounts to being off by just a single day over a span of 5,000 years. This was not a lucky guess. It was the result of a sustained scientific project spanning countless human lifetimes. Their astronomical prowess extended far beyond our own sun. The planet Venus, known to them as Noek, the Great Star, held immense religious and practical significance, governing the timing of warfare and the fates of kings. They tracked its complex dance with the sun, a cycle known as the synodic period, with a precision that is difficult to fathom. The Maya calculated this period, the time it takes for Venus to return to the same position relative to the Sun as seen from Earth, as 584 days. The modern measurement is 583.92 days. To achieve this, they devised a sophisticated ratio, understanding that 5 Venus cycles very nearly equaled 8 solar years of 365 days each. This allowed them to harmonize the movements of the Sun and Venus within their calendar, predicting its appearances as both the morning and evening star with unerring accuracy for centuries into the future. None of this would have been possible without the foundation of their revolutionary mathematical system. While much of the world struggled with cumbersome Roman numerals or other primitive counting methods, the Maya had developed an elegantly simple place value system, much like our own, and they had a full conception of the number 0. Their system used only 3 symbols, a shell for 0, a dot for 1, and a bar for 5. By arranging these symbols vertically, they could represent any number imaginable. The power of this system cannot be overstated. The concept of 0 as a placeholder is one of the most profound intellectual discoveries in human history, allowing for efficient arithmetic and the representation of very large numbers, which was essential for their long count calculations. A European mathematician of the same era would have had no such tool, making the complex astronomical computations routine for Maya scribes utterly impossible for their counterparts across the ocean. This synergy of mathematics and observation allowed them to tackle even more complex celestial relationships. They carefully tracked the lunar cycle, developing what is known as the lunar series, which corrected their calendar to keep it in sync with the moon's phases over long periods. They also understood the precession of the equinoxes, the slow, wobbling drift of Earth's axis that completes a cycle every 26,000 years. Evidence suggests their calendar systems were designed to align with this grand celestial clock, demonstrating a cosmological vision that stretched across millennia. When we look at the stark, beautiful numbers carved into a Mayan stela, we are not looking at primitive superstition. We are looking at the output of one of the most sophisticated scientific cultures the world has ever known, a civilization that mapped time with the same precision we now map the globe, and whose intellectual achievements in the heart of the jungle stand as a permanent monument to the power of the human mind to decode the universe. But the grand, sweeping cycles of Mayan timekeeping offer a stark contrast to our next artifact, a small, fired clay disc that holds a message so personal and specific that it has stubbornly refused to reveal its secret for over 3,000 years. Unearthed in 1908 within the ruins of the Minoan Palace of Phaistos on the island of Crete, the Phaistos disc is an object of profound and beautiful mystery. It's a humble piece of baked clay, roughly the size of a small plate, and on both of its faces, a continuous spiral of symbols is stamped, marching from the outer edge relentlessly towards the center. There are 241 of these tiny pictographs in total, arranged into 61 distinct groups, separated by incised lines that seem to mark out individual words or phrases. The images themselves are wonderfully varied and evocative: a helmeted head, a bird in flight, a walking man, a beehive, a ship, a shield, and many more. On the surface, it looks like it should be readable, a simple list or a short story waiting to be understood. Yet, despite over a century of intense effort by the world's most brilliant linguists, cryptographers, and archaeologists, the disc remains completely undeciphered. Its purpose, its meaning, and the very language it encodes are a sealed book, making it one of archaeology's most famous and frustrating enigmas. The first layer of the mystery lies in its absolute isolation. The disc was created around 1700 BC, in the heart of the sophisticated Minoan Bronze Age civilization. We have found thousands of other clay tablets from this period and region, inscribed with several known scripts, including the earlier hieroglyphic Cretan script and the later, still mostly undeciphered lineae. But the Phaistos disc is utterly unique. Its symbols do not appear anywhere else, not on a single part, not on a wall, not on any other piece of clay. It is a hapax legomenon of the physical world, a one-of-a-kind document. This singularity is what makes the decipherment problem so intractable. In code-breaking, context is everything. The famous Rosetta Stone was decipherable because it presented the same text in 3 different scripts, one of which was known. With the Phaistos disc, there is no parallel text, no bilingual inscription, no Rosetta Stone to provide a key. Every attempted translation, and there have been hundreds, proposing it is everything from a religious hymn and a royal proclamation to a geometric theorem or an ancient board game, is ultimately a shot in the dark, an educated guess that cannot be verified because there is nothing to verify it against. Yet, the most technologically mind-bending aspect of the disc is not the symbols themselves, but how they were applied. Each symbol was not carved by hand. Instead, they were stamped onto the soft clay using pre-formed movable type seals. This is a revolutionary concept. The artisan who created this object had a set of individual punches, each one bearing a specific pictograph, and they pressed these punches into the clay in a specific sequence to form the spiraling text. This makes the Phaistos disc the earliest known example of movable type printing in human history. Let that sink in for a moment. This technology, which we associate with Johannes Gutenberg's invention in the 15th century that revolutionized communication in Europe, was being used in the Mediterranean over 3,000 years earlier. It represents a conceptual leap of staggering proportions. The understanding that a written message could be composed from a reusable set of standardized characters, a principle that lies at the very heart of modern printing and computing. And then, just as suddenly as it appeared, the technology vanished. There are no other examples of stamped documents from Minoan Crete. No other sets of type have ever been found. It's as if this one individual or this one workshop had a brilliant, fleeting idea, a spark of genius that illuminated the potential of a new form of communication. And for reasons we can never know, that spark failed to catch fire. Perhaps the type was lost or destroyed. Perhaps the scribble class, whose power was based on their exclusive ability to hand-write documents, actively suppressed the technology. Or perhaps it was simply a local innovation that was rendered obsolete by the cataclysmic volcanic eruption on Thera that destabilized the entire Minoan civilization shortly after the disc was made. Whatever the reason, this single artifact stands as a perfect, poignant symbol of a technological road not taken. It is a ghost of an alternate history, a whisper of a path where the printing press might have evolved in the Bronze Age, changing the entire trajectory of literacy and knowledge distribution in the ancient world. The Phaistos disc, therefore, is a double mystery. It is an unreadable message locked inside a technological anomaly, a solitary beacon from the past whose light shines brightly but illuminates nothing but its own profound and beautiful isolation. As remarkable as the Antikythera Mechanism is, it was not an isolated spark of genius in a sea of technological darkness. It represented the apex of a much broader and more vibrant culture of mechanics and engineering in the ancient Greek world, a tradition whose echoes can be found in tantalizing references and surviving fragments that point to a parallel history of automation and mechanical thinking. While the Antikythera device stands as our most complete and complex artifact, it serves as a powerful indicator of a lost world of sophisticated gadgets and automated wonders, many of which were created by figures whose names have been preserved, but whose full legacy has been largely forgotten. One of the most prolific of these inventors was Hero of Alexandria, a 1st century AD engineer and mathematician who operated in the great intellectual center of the Mausoleum at Alexandria. His surviving manuscripts, such as the Pneumatica and the Automata, read like catalogues of science fiction concepts brought to life. He described and likely built devices powered by steam, water, air pressure, and falling weights that performed tasks with a level of automation that seems to belong to a much later era. Consider his famous Eolipile, often called the world's first steam engine. This device was a hollow metal sphere mounted on a boiler. As the water in the boiler heated, steam was channeled through pipes into the sphere, which then expelled it through 2 bent nozzles, causing the entire sphere to spin rapidly on its axis. This was not just a curious toy, it was a practical demonstration of the principle of action and reaction, the very foundation of jet and rocket propulsion, invented purely as a demonstration 2,000 years before it would be harnessed for industry. Hero's imagination extended far beyond prime movers into the realm of automated theater and public spectacle. He designed intricate mechanical plays, complete with automated puppets that could perform an entire narrative without human intervention. In one described automaton, a small, self-powered theater would present the myth of Nauplius. Doors would open automatically on a timer, revealing miniature figures inside. These figures, driven by a complex system of weights, strings, and twisted cords acting as programmed rotors, would move across the stage. Ships would sail, fires would appear to blaze, and figures would gesture, all driven by a falling weight that provided the power, and a system of knots and strings that provided the timing and sequence, a primitive form of binary programming. He even designed automatic temple doors that would appear to open by divine command when a priest lit a fire on an altar. The heat would expand air in a sealed container, forcing water into a bucket that acted as a counterweight, causing the doors to swing open, mesmerizing the faithful and demonstrating a breathtaking application of basic physics to create a sense of magic. These were not mere philosophical musings. Archaeological finds and other historical accounts suggest a wider culture of mechanical application. Archimedes, a century before Hero, was renowned not just for his mathematical theorems but for his terrifying war machines used to defend Syracuse from the Romans, including giant clawed cranes that could lift enemy ships out of the water. The Roman architect Vitruvius described the construction of odometers for measuring distance traveled by carts, using a complex series of gears that would drop a stone into a box after every Roman mile. Ancient texts refer to automatic wine dispensers that mixed wine and water in precise proportions, and even a coin-operated holy water vending machine, again attributed to Hero, where inserting a coin would trigger a lever mechanism that released a measured amount of water. This reveals a society that was actively thinking about how to use mechanics to replace or augment human labor, to entertain, to worship, and to measure the world with greater precision. The profound and somewhat haunting question this raises is why this thread of technological progress was ultimately cut. The Greeks and Romans had a conceptual understanding of steam power, gearing, automation, and programmable sequences. They possessed the materials and the metalworking skill, so why did their civilization not launch an industrial revolution? The answer lies in a complex web of social and economic factors, not a lack of intellect. The ancient economy was fundamentally built on slave labor. there was little economic incentive to develop labor-saving machinery on a massive scale when human power was so abundant and cheap. Furthermore, these inventions were often seen as curiosities, playthings for the wealthy or religious wonders, rather than tools for transforming production. Knowledge was esoteric, held by a small elite, and not systematically disseminated or built upon across generations. When the great libraries like Alexandria declined and the Roman Empire fractured, this fragile thread of mechanical knowledge was lost, fragmented, or simply no longer prioritized. The blueprints gathered dust, and the principles they demonstrated would have to be painfully rediscovered over a millennium later. The automata of Hero and the gears of the Antikythera Mechanism represent a road not taken, a vivid demonstration that the potential for a different technological trajectory existed in the ancient world, waiting for a social and economic context that would never arrive to nurture it into full bloom. From the intricate automata of Alexandria, let's turn to a Roman innovation that brought warmth and comfort to daily life on a scale that would be impressive even today. Imagine stepping into a Roman bathhouse in the heart of a cold British winter. Instead of a drafty, stone-cold floor, your bare feet meet warm, polished tile. The air around you is pleasantly heated, rising from the floor itself, allowing you to relax in a tunic while snow falls outside. This wasn't magic. It was a masterpiece of civil engineering called the hypocaust, a centralized heating system that transformed living spaces and stands as a stunning example of how Roman comfort and luxury were underpinned by brilliant, practical technology. The principle was elegant yet powerful. The system worked by creating a hollow space or plenum beneath the floor of a building. Stonemasons would first construct a series of short, sturdy pillars, typically made of stacked terracotta bricks or stone, spaced evenly across the foundation. On top of these pillars, they would lay large, flat tiles to form the solid subfloor. Then, the finished floor, often a beautiful and durable mosaic made of thousands of tiny colored tiles, was set on top. Meanwhile, at one end of the building, often in an external service room, a large wood or charcoal-fired furnace, known as a prefernium, was kept constantly burning. The hot gases and air from this furnace were not simply vented out a chimney. Instead, they were channeled directly into the open space beneath the raised floor. This hot air would then circulate freely through this man-made underground cavity, gently and consistently heating the entire floor slab above it. But the Roman engineers didn't stop there. They found a way to capture the escaping heat that would otherwise be wasted. The walls of the most luxurious baths and villas were also part of the system. Within the walls, they installed rectangular terracotta tubes called tubuli, which were stacked and interlocked to form hollow channels from floor to ceiling. As the hot air from under the floor naturally rose, it would be drawn into these wall cavities, heating the bricks and plaster before eventually exiting through flues built into the roof. This created a comprehensive heating envelope, warming a room from the floor and the walls simultaneously. The result was an even, radiant heat that avoided the stuffiness and dryness associated with many modern forced air systems. The temperature could even be regulated somewhat by the intensity of the furnace fire and by opening or closing dampers in the wall flues, giving building managers a surprising degree of control over the climate inside. The hypocaust was more than just a technical novelty. It was a powerful symbol of Roman identity and a marker of a civilized life. While the wealthy enjoyed these systems in their private villas from Britain to Syria, it was in the public bathhouses, the thermae, that the technology achieved its most spectacular and democratic expression. These vast complexes were central to Roman social life, and the hypocaust was the engineering heart that made them possible. It heated the warm room, the tepidarium, and the intensely hot steam room, the coldarium, where bathers would work up a sweat before plunging into a cold pool. The system allowed these massive public buildings, with their soaring ceilings and expansive floors, to remain welcoming year-round, reinforcing the Roman ideal of public leisure and communal hygiene. The fuel consumption was enormous, requiring entire forests to be managed for firewood, a cost that only a highly organized and wealthy society could sustain on such a scale. The true measure of its sophistication, however, is revealed by what happened after the fall of the Roman Empire. With the collapse of centralized authority, organized fuel supply chains, and the specialized knowledge required for their construction and maintenance, hypocaust systems fell into disuse and were eventually forgotten throughout most of Europe. For over a millennium, the concept of central heating vanished from the continent. During the Middle Ages, warmth came from inefficient and smoky open hearths in the middle of a great hall, with heat rising to the rafters and leaving those on the periphery cold. It wasn't until the 17th and 18th centuries that rudimentary systems mimicking the Roman principle began to slowly reappear, and not until the 19th century, with the advent of steam and hot water systems, did central heating become common again. This staggering technological regression, a gap of over 1,200 years, underscores just how advanced Roman civil engineering truly was. The hypocaust was not an incremental improvement. It was a monumental leap in living standards, a comfortable, radiant warmth that would not be felt again in Europe until the dawn of the modern industrial age. Now, let us journey to the high Andes of Peru, where the legacy of the Inca Empire is etched not in delicate mechanisms or written texts, but in the staggering, monumental silence of their stonework. At sites like the fortress of Sacsayhuaman, looming over the city of Cusco, or the terraced stronghold of Ollantaytambo in the Sacred Valley, you are confronted by a sight that defies easy explanation. Here, massive blocks of stone, some weighing over 100 tons, are assembled into walls with a precision that borders on the impossible. These are not simple, rectangular bricks. The stones are polygonal, possessing a dizzying array of angles and curves, each one uniquely shaped to interlock perfectly with its neighbors in a colossal, three-dimensional jigsaw puzzle. The fit is so exact, so seamless, that you cannot slide a piece of paper or even a razor blade between them. This is not mere construction. It is a form of lithic magic, a stonecutter's dream achieved on a gargantuan scale, and it has withstood centuries of violent earthquakes that have routinely leveled the Spanish colonial buildings erected on top of them. The mystery begins with the quarrying and the mind-boggling transportation of these behemoths. The granite for Ollantaytambo, for instance, was sourced from a quarry high on a mountainside across the Urubamba River and a vast plain. How did a culture without the wheel, without draft animals stronger than the llama, and without advanced pulley systems move these 100-ton blocks? The prevailing theory suggests they used an army of laborers, dragging the stones on rolling logs or sliding them on slick clay surfaces lubricated with water. This itself is a monumental feat of logistics and human power, requiring the coordination of thousands of people to inch a single block across miles of difficult terrain, up and down steep slopes. The stone itself shows evidence of this journey, with protuberances left on some blocks that may have served as handles for ropes, later knocked off once the stone was in its final position. But the truly perplexing part, the element that fuels endless speculation, is the final shaping and placement. How did the Inca stonemasons achieve that legendary airtight fit? The conventional academic explanation involves a patient, iterative process of trial and error. They might have used a method called pillow and face, where one stone was positioned, and then a second was laboriously shaped by repeatedly rubbing a harder stone against it, perhaps with sand and water as an abrasive, to slowly grind a matching impression. They could have used wooden templates or lead casts to transfer the complex negative shape of the already placed stone onto the new block. This theory paints a picture of incredible patience and skill, where stones were trial-fitted, marked, ground down, and fitted again over and over until the joint was perfect. While this explains the precision, it seems almost unimaginably slow and labor-intensive, even for a society with the immense manpower resources of the Inca Empire. This gap between the conventional explanation and the sheer perfection of the result has given rise to more exotic and highly controversial theories. One of the most captivating is the idea that the Incas possessed a lost technology for softening stone. Proponents point to local legends and even some colonial chronicles that describe a plant-based liquid that, when applied to the rock surface, would make it pliable like clay. In this scenario, workers would not need to grind the stones for months. They could simply press a softened block against its neighbor, and it would conform to the exact shape, hardening back into solid granite as the substance wore off. While no such plant has been definitively identified and no chemical residue has been found on the stones, the theory persists because it offers an elegant solution to an otherwise baffling problem. Even more speculative are the theories involving sonic levitation or acoustic manipulation. These ideas draw from various global myths and a handful of ambiguous historical references suggesting that certain ancient cultures used sound to make massive objects weightless. The concept is that priests or engineers, using drums, chanting, or other instruments, could generate a specific resonant frequency that would counteract gravity, allowing large groups of people to guide the massive stones into place with minimal effort. While there is no direct archaeological evidence for this, and it ventures firmly into the realm of pseudo-archaeology for most mainstream scholars, it highlights the profound sense of awe that Inca masonry inspires. When faced with such an achievement, the human mind sometimes reaches for explanations that seem as monumental as the stones themselves. Regardless of the method, the ultimate genius of Inca stonework may lie in its brilliant engineering outcome: unparalleled earthquake resistance. The irregular, interlocking polygonal design is actually the key to its seismic resilience. During an earthquake, the ground shakes in complex, multi-directional waves. A wall made of uniform, rectangular blocks with straight mortar joints is rigid. When the earth moves, the wall cannot flex and the mortar crumbles, causing the entire structure to collapse. The Inca walls, however, are fundamentally flexible. The complex, jigsaw-like joints and the absence of mortar allow the individual stones to vibrate, shift, and even bounce minutely during a tremor. When the shaking stops, the stones, locked together by their own weight and intricate shapes, simply settle back into their original positions. They dance with the earthquake rather than fighting it. This is a profound understanding of dynamic loads and structural integrity, an empirical knowledge of seismic engineering that was encoded directly into their architecture. The enduring, silent presence of Sacsayhuaman is not just a mystery of how it was built, but a lasting lesson in how to build for eternity. A masterclass in resilience carved in stone by a civilization whose deepest secrets are still locked within the perfect seams of their impossible walls. Now, let's turn our attention to an object so delicate and mysterious it seems to capture a magical property of light itself. Housed in the British Museum is a stunning Roman artifact from the 4th century known as the Lycurgus cup. At first glance, it's an exquisite example of Roman cage cup glasswork, a deep, jade-like green when viewed in reflected light. But tilt it or shine a light from within, and something extraordinary happens. The entire vessel transforms, glowing with a vibrant, translucent ruby red. For centuries, this color-changing miracle was seen as a kind of ancient alchemy, a secret lost to time. It wasn't until the 1990s, with the advent of the electron microscope, that researchers were able to peer into the very fabric of the glass and uncover a secret hidden for over 1,600 years. The Romans, whether by brilliant design or incredible accident, had become masters of nanotechnology. The magic of the cup is not in the glass itself, but in what is suspended within it. Analysis revealed that the glass contains tiny, precise particles of gold and silver, but these aren't mere specks of dust. They are nanoparticles measuring between 50 and 100 nanometers in diameter. To grasp just how small that is, a single nanometer is 1/1000th of a meter. these particles are so minute that they are smaller than the wavelength of visible light. This microscopic cocktail is a form of what scientists now call a colloidal suspension, a substance where tiny, insoluble particles are evenly dispersed throughout another material. The Romans achieved this by mixing crushed glass with gold and silver dust in very specific, minuscule proportions, and then carefully heating and cooling the mixture. The result was a composite material with properties that neither metal nor glass possessed on its own. The science behind the color change is a phenomenon known as surface plasmon resonance. When light hits these embedded metal nanoparticles, it interacts with the cloud of electrons buzzing around each particle's surface. In the particles of gold, this electron cloud is set oscillating or resonating at a specific frequency. When the cup is lit from the front in reflected light, our eyes primarily see the green and blue wavelengths of light that are scattered away by these resonating particles. But when light shines from behind the cup passing through the glass, the resonance captures and absorbs the blue-green wavelengths while allowing the red wavelengths to pass straight through to our eyes. The silver nanoparticles in the mix likely serve to fine-tune this effect, modifying the resonance to produce the specific, rich ruby hue. This isn't a simple filter or dye. It's an active, physical manipulation of light at a submicroscopic level, a principle that underpins modern technologies from medical diagnostics to high-resolution displays. The staggering question, of course, is whether this was a deliberate innovation or a miraculous fluke. The precision required is breathtaking. The artisans had to get the composition of the metals exactly right. Too much gold or silver, and the effect would be lost, the glass turning opaque or a dull color. They also had to control the heating process with incredible care to prevent the nanoparticles from clumping together into larger, ineffective clusters. This suggests a deeply sophisticated, even if empirical, understanding of materials. It's unlikely the Roman glassmakers understood quantum physics, but they had clearly mastered a recipe through rigorous experimentation and observation. They knew that adding a tiny, precise amount of gold dust to a particular batch of glass and treating it with a specific thermal cycle would produce this wondrous optical effect. This points to a tradition of glassmaking that was not just a craft, but a form of experimental materials science. The Lycurgus cup is not a solitary anomaly. A handful of other Roman glass fragments exhibiting similar dichroic or color-changing properties have been found, indicating this was a known, if exceedingly rare and valuable, technique. This makes the case for accidental discovery much weaker. The consistent, repeatable results across different objects suggest a controlled process, a secret formula passed down within a specific workshop or guild of master glassmakers. The cup's incredible survival allows us a glimpse into a pinnacle of Roman technical artistry that was almost entirely lost after the fall of the empire. The knowledge of how to create this nanoparticle-infused glass vanished for over a millennium and a half, only being rediscovered in the modern era with the help of multi-million-dollar electron microscopes. The cup thus stands as a dual symbol. It is a beautiful artifact of ancient luxury, but it is also a quiet, resounding testament to a level of practical nanotechnology that we thought was the exclusive domain of our own time. While the precision of Inca masonry and the nanotechnology of the Lycurgus cup represent physical marvels, our next artifact presents a different kind of mystery, one etched not in stone or glass, but in vellum and an utterly baffling script. Tucked away in the Beinecke Rare Book and Manuscript Library at Yale University is a small, unassuming book that has defied understanding for over 6 centuries. This is the Voynich manuscript, a 240-page codex carbon dated to the early 15th century, and it is arguably the most stubbornly enigmatic book in the world. Its pages are filled from edge to edge with graceful, looping characters from an alphabet that does not match any known language. Accompanying this unknown text are hundreds of illustrations that are somehow both meticulous and nonsensical. depicting a universe of plants that have never grown on Earth, astrological charts with unfamiliar constellations, and drawings of petite, nude women bathing in what appears to be a system of interconnected green pools. From the moment it resurfaced in the modern era, it has been a siren call for the world's greatest codebreakers, linguists, and historians, all of whom have been utterly defeated by its contents. The manuscript is systematically divided into sections based on its illustrations, each one more perplexing than the last. The so-called herbal section makes up the bulk of the book, filled with illustrations of flora that are botanically plausible yet completely unidentifiable. Each plant is rendered with fine roots, leaves, and stems, but they are often composite creatures, with one plant having the leaves of 3 different known species, or a root system that belongs to an entirely different genus. Then there is the astronomical section, featuring circular diagrams of medallions containing suns, moons, and stars. These aren't standard zodiac symbols, they are unfamiliar, with nymph-like figures residing in the spokes of what looks like a celestial wheel. Another section, often called the biological portion, is the most bizarre, showing those numerous naked women, often oddly proportioned, submerged up to their waists in intricately plumbed green baths or tubs, connected by a network of pipes and vessels that suggest some kind of alchemical or physiological process. There is a pharmaceutical section with drawings of tiny jars and plant parts, resembling a medieval apothecary's guide, and finally, a section of unbroken text, lacking any illustrations at all, that may be the book's conclusion or its deepest secret. The relentless, century-long assault on the manuscript's code is a story of brilliant failures. During World War II, a team of top American cryptographers from the group that had just broken Japan's purple cipher turned their collective genius to the Voynich, confident they could crack it in their spare time. They failed. Decades later, the brilliant cryptanalyst William Friedman, who had been instrumental in the Allied code-breaking efforts, assembled a dedicated team to tackle it. After years of work, they too retired, baffled. With the advent of computers, statistical analysts have subjected the text to every possible test. They've confirmed that the manuscript's language has a structure. Its word entropy and letter distribution resemble those of a natural language, not random gibberish. Certain words follow patterns that suggest grammar and syntax. This statistical validation makes the mystery even deeper. It implies there is a real, structured message there, one that has withstood the most powerful analytical tools of the 20th and 21st centuries. The sheer resilience of its cipher, unbroken by minds that unlock the most complex military codes of their day, grants the manuscript an almost supernatural aura. This profound resistance to decryption has naturally spawned a vast spectrum of theories. The most pragmatic, and to some, the most disappointing, is that the entire manuscript is an elaborate and skillful hoax. Proponents of this view, which has gained traction in recent years, suggest it could have been created by a clever forger, perhaps even its one-time owner, the 17th century alchemist Georg Bersch, to sell a mysterious book to a wealthy patron. They argue that the text could be a form of proto-gibberish, crafted with just enough structure to mimic language without containing any meaning at all. A sophisticated form of nonsense designed to mystify and deceive. The strange plants in this scenario are simply products of a fertile imagination. Yet, the incredible effort involved in creating over 200 pages of meticulously penned fake text and intricate, unique drawings seems an immense labor for a simple fraud, raising the question of what the forger could possibly have gained from such an arduous deception. On the other end of the spectrum are the more extraordinary explanations. Some researchers have tirelessly argued that it is an encoded scientific or medical text, perhaps containing heretical knowledge that needed to be concealed from the church. The bathing nymphs could represent a lost understanding of human physiology, linked to the lymphatic system or the circulation of bodily fluids. The unidentifiable plants might be depictions of New World species, drawn by an early European explorer who encountered a flora so alien he had to invent a new way to describe it, a theory that places the manuscript's origins in the Age of Discovery. The most tantalizing theory, though now largely debunked by carbon dating, was that it was the work of the 13th century English friar Roger Bacon, a man known for his interest in cryptography and advanced science, potentially containing secrets of alchemy or optics that were centuries ahead of their time. A compelling modern hypothesis which tries to bridge the gap between the hoax and code theories is that the manuscript is an example of an encoded, abbreviated language specific to a small, niche community. It might not be a cipher of Latin or German, but a constructed script for a particular discipline, like a medieval shorthand for herbalists or astrologers, where each word is an encoded recipe or astrological observation. The text's unusual word structure, with very few repeated words and a limited alphabet, could support this idea of a highly specialized verbose code. The Voynich manuscript, therefore, stands as a permanent monument to the limits of our knowledge. It is a locked door from the past for which the key has been lost. Its value lies not in the secrets it might contain about alchemy or unknown plants, but in the profound intellectual challenge it represents. It is a mirror reflecting our own desire to solve, to categorize, and to understand. A silent, beautiful, and endlessly frustrating reminder that the past can still hold mysteries that our most advanced minds cannot unravel. While the Romans were perfecting central heating and the Incas were mastering seismic engineering, an entirely different kind of genius was flourishing in the ancient world, one that looked inward to the intricate and fragile landscape of the human body. For this, we travel to the banks of the Ganges River in ancient India around 600 BC to the teachings of a legendary physician known as Sushruta. His legacy, compiled in the monumental text the Sushruta Samhita, presents us with a medical system so sophisticated, so systematic, and so daring that it reads less like an ancient manuscript and more like the curriculum for a modern medical school. This was not a collection of superstitions and prayers. It was a rigorous empirical science of surgery, detailing procedures that would not become common in the West for over 2 millennia. The text begins with a foundation that any modern surgeon would recognize: the absolute necessity of practical, hands-on training. Sushruta established what might be considered the world's first surgical residency program. He insisted that his students could not learn surgery from books or lectures alone. They had to develop a tactile, three-dimensional understanding of human anatomy and the feel of a blade long before they ever touched a living patient. To achieve this, he devised a series of brilliant and innovative training exercises. Students would practice making precise incisions on fruits and vegetables, the water-filled stem of a watermelon to simulate a fluid-filled cyst, or the soft pulp of a gourd to learn the control needed for deeper tissue. They practiced suturing on pieces of cloth or leather, and perhaps most remarkably, they learned the delicate art of probing and extraction by using models where objects were hidden within the soft, dark flesh of a fruit, forcing them to rely on touch and dexterity rather than sight alone. This methodical approach to building fundamental skill was unprecedented in the ancient world. When it came to the operating theater itself, Sushruta and his followers wielded an astonishing array of 125 different surgical instruments, many of which are eerily recognizable today. These were not crude blades of stone or bronze. They were specialized tools forged from iron, each designed for a specific and delicate task. The text describes swastikas forceps, sandansas tweezers, and nollas tubular drains. There were different types of scalpels, scissors, probes, and hooks, each with a specific name and a defined purpose. There were speculums for examining body orifices, rectal dilators, and specialized needles for suturing. The sophistication of this toolkit reveals a profound understanding of mechanical principles and a commitment to minimizing tissue trauma, principles that remain the bedrock of modern surgery. This advanced toolset enabled them to perform operations that seemed to defy the timeline of medical history. One of the most celebrated procedures described is the reconstruction of a nose or rhinoplasty. In an era where cutting off the nose was a common punishment for criminals or adulterers, Sushruta developed a method to restore both form and function. The technique involved cutting a flap of skin from the patient's cheek, carefully leaving it attached at one end to preserve its blood supply. This living flap was then twisted and grafted onto the stump of the nose, with two hollow tubes of reed or wood inserted to serve as artificial nostrils, keeping the airway open during the healing process. The precision required to ensure the graft took hold, the understanding of tissue viability, and the consideration of both aesthetic and functional outcomes is nothing short of revolutionary for its time. But their expertise extended far beyond the surface. The Sushruta Samhita provides detailed instructions for cataract surgery, a procedure to cure blindness caused by the clouding of the lens. The surgeon would use a slender, needle-like instrument called a Jabamukhi Saloka. After carefully positioning the patient and stabilizing the head, the surgeon would insert the needle through the edge of the cornea. With a series of precise, controlled movements, they would then gently push the clouded lens downward and out of the field of vision, a technique known as couching. While this did not remove the cataract, it allowed light to once again enter the eye, restoring sight. The manual dexterity and anatomical knowledge required to perform this inside the eye without causing irreparable damage or infection is staggering to contemplate. Perhaps one of the most inventive and resourceful techniques recorded involves wound closure using live ants. For sealing intestinal wounds or other deep tissues where suturing was difficult, Sushruta described using large black ants. The live ant would be positioned so its mandibles clamped shut across the edges of the wound, effectively acting as a staple. Once the ant had bitten down and secured the tissue, its body would be snapped off, leaving the head and powerful jaws in place as a perfect, sterile, and biodegradable suture. This displays not just a creative problem-solving mindset, but also a keen observation of nature and a willingness to harness biological mechanisms for medical purposes. The scope of their practice was breathtakingly comprehensive. The text describes procedures for draining abscesses, removing bladder stones, and repairing anal fistulas. It details the set of symptoms for diagnosing diabetes and remarks on its association with sweet-tasting urine. It even includes instructions for what we would now recognize as a cesarean section, performed when the life of the mother was in jeopardy during a difficult childbirth. All of this was underpinned by a sophisticated understanding of antisepsis, with physicians instructed to fumigate the operating theater with fumes of mustard and other herbs to maintain strict cleanliness and to use alcohol and hot oils to cleanse wounds. The Sushruta Samhita represents a complete, holistic medical system, one that viewed surgery as a sacred, life-saving art and laid a foundation of empirical knowledge and practical skill that would not be matched in the West until the scientific revolution 2,000 years later. Our journey through the annals of ancient ingenuity now takes us deep into a crypt beneath the Egyptian desert, to a chamber that holds a carving so peculiar it has sparked a debate raging for decades. Within the Temple of Hathor at Dendera, on a subterranean wall, there is a series of stone reliefs that, to a modern eye, look astonishingly out of place. One large, distinct panel shows a scene that has become legendary in alternative history circles. It depicts what appears to be a giant, pear-shaped light bulb. Inside this bulb, a snake stretches the length of the vessel, its head pointing toward one end. This filament is held in place by a supporting pillar, and the entire bulb is connected by a thick, cable-like cord to a box upon which stands a kneeling god. Next to this mysterious apparatus stands a baboon-like deity holding two knives, which proponents of the theory interpret as a warning of danger or high voltage. This is the famous dendrolite, and for those who believe in lost ancient technologies, it is one of the most compelling pieces of evidence that the Egyptians might have harnessed electric light. The arguments put forward by the ancient electricity theory are compelling when viewed through a modern lens. They ask us to consider the practical challenges the Egyptians would have faced in decorating their vast, intricate subterranean tombs, like those in the Valley of the Kings. These tombs are covered from floor to ceiling with perfectly executed hieroglyphs and paintings, all executed in pitch-black darkness, deep within solid rock. How could such detailed work be accomplished without a powerful, portable light source? Torches would have consumed precious oxygen and left sooty residue on the ceilings, yet no such staining is found. Oil lamps, the conventional explanation, produce a dim, flickering light that would cast confusing shadows, making it nearly impossible to achieve the precision seen in these tombs. The dendra relief, they argue, provides the answer. They interpret the scene as a literal depiction of an electric lamp in operation. The snake represents the glowing filament, the pear-shaped object is the glass bulb, the pillar is an insulator, the cable is an electric wire, and the box on which the god kneels is the power source, perhaps a primitive battery not unlike the Baghdad Battery. The baboon with the knives is seen as a symbolic warning about the deadly power contained within this device, a piece of instructional iconography for the priests who may have operated this sacred technology. However, when we turn to the vast majority of professional Egyptologists and archaeologists, we are presented with a completely different and far more contextually grounded interpretation. They explain that the relief cannot be understood in isolation. It is one part of a much larger mythological narrative covering the temple walls, a story deeply rooted in the Egyptian cosmos. The mainstream view identifies the bulb not as a technological device, but as a lotus flower, a symbol of creation and rebirth. In Egyptian mythology, the lotus is the flower from which the sun god first emerged at the dawn of time. The snake is not a filament, but a representation of the deity Harsomptus, a form of the god Horus, who is born from the lotus. The cable is interpreted as the snake's own umbilical cord, connecting it to the lotus, symbolizing its origin and life force. The entire scene, therefore, is a visual representation of a fundamental creation myth, the emergence of life and divine power from the primordial waters, depicted through the symbiotic relationship of the lotus and the serpent. The supporting elements of the scene reinforce this mythological reading. The kneeling god attached to the wire is Her, a deity symbolizing infinity and eternity, often shown holding notched palm ribs representing long life. His presence emphasizes the cyclical, eternal nature of creation. The baboon figure is likely the god Thoth, associated with the moon, wisdom and measurement, or the god Babai, a fierce guardian of the afterlife. The knives he holds are not a warning about electricity, but are apotropaic, meant to ward off evil spirits and protect this sacred moment of creation. To see this panel as the Egyptians themselves would have requires immersing ourselves in their symbolic language, where every element is a piece of a spiritual and cosmological puzzle, not a technical diagram. The ancient artists were not documenting an electrical workshop. They were illustrating the very moment the world was born from the petals of a flower, a story they told and retold for thousands of years. So why does the light bulb interpretation continue to hold such powerful sway over our imagination? The enduring allure of the dendra light speaks to a deeper human desire, the longing for a lost golden age, a time when our ancestors possessed wisdom so profound it has since been forgotten. This idea is far more romantic and thrilling than the slow, painstaking progress of archaeological consensus. It taps into a narrative of a great cataclysm, perhaps the fall of Atlantis, that reset human civilization and erased advanced knowledge, leaving behind only cryptic clues in stone. The dendra carving is a perfect Rorschach test for this belief. Its clean, geometric lines and the snake's uncanny resemblance to a glowing filament create a powerful cognitive shortcut. For a modern person, it is instantly recognizable as a light bulb, and this initial, visceral recognition can be difficult to overcome, even when presented with the complex mythological framework that experts provide. The theory offers a simple, elegant solution to the practical problem of tomb lighting, one that feels more satisfying to some than the idea of artists working for generations in near-total darkness. Ultimately, the Dendera light stands at a fascinating crossroads between rigorous academic interpretation and boundless popular speculation. It is a testament to the power of pareidolia, the human tendency to see familiar patterns like a light bulb in ambiguous stimuli. While the evidence strongly supports the mythological explanation, the relief's persistence as an icon of alternative history highlights an important truth about how we engage with the past. We are often drawn to narratives that collapse the distance between ancient and modern, that suggest a direct, tangible connection to our ancestors' supposed technological prowess. The real wonder of Dendera may not be a question of whether the Egyptians had electric light, but why we are so captivated by the idea that they did. It reveals our own fascination with the possibility that history holds secrets far grander than we have yet been willing to accept, and that the line between ancient myth and modern science might be thinner and more blurred than we ever imagined. Yet another enigma carved in stone awaits us, not in a dark crypt, but high on a temple wall in the ancient Egyptian city of Abydos. Here, within the temple of Seti I, is a set of hieroglyphs that has become an internet sensation and a cornerstone of alternative history. Gazing up at the lintel above a doorway, you'll see a collection of symbols that seem to defy all chronology. To the modern eye, one looks unmistakably like a helicopter, complete with a cockpit and a tail rotor. Right beside it, another carving resembles a submarine or a zeppelin, while a third appears to depict a futuristic jet plane or perhaps even a hovercraft. It's a jaw-dropping sight, a collection of 20th century machinery seemingly etched into a 3,000-year-old monument, and it has fueled endless speculation that the Egyptians must have seen, or perhaps even possessed, incredibly advanced technology. The most captivating theories spun from this visual are indeed extraordinary. Proponents of the ancient astronaut hypothesis point to the Abydos carvings as potential proof of extraterrestrial visitations, suggesting these are records of advanced vehicles observed by the pharaohs. Others propose an even more radical idea that a highly advanced human civilization, like Atlantis, existed in prehistory and that its technological legacy was recorded by the early Egyptians before being lost to time. The sheer clarity of the helicopter shape makes it a powerful piece of evidence for these views, appearing as a literal snapshot from another era accidentally preserved in stone. It seems to be a direct challenge to our linear understanding of progress, a piece of undeniable anachronistic proof. However, mainstream archaeology offers a compelling and far less sensational explanation, one rooted in the practical realities of ancient Egyptian stonemasonry and a fascinating process known as palimpsest. The key to understanding the Abydos helicopter lies not in time travel or lost civilizations, but in the simple act of political revision. The temple was originally commissioned by Pharaoh Seti I, and the inscriptions celebrated his name and titles using traditional royal epithets. When his son, the great Ramesses II, ascended to the throne, he often embarked on ambitious building projects and frequently usurped his father's monuments to strengthen his own legacy. At Abydos, workmen were tasked with erasing Seti's names and cartouches and recarving the plaster filling of the hieroglyphs to insert Ramesses' names in their place. This is where the visual magic happens. The craftsmen didn't completely chisel away the older, deeper carvings. Instead, they applied a new layer of plaster and carved the new hieroglyphs directly over the old ones. Over centuries, this plaster has crumbled and fallen away in patches. What we see today is not a single, coherent image, but a complex palimpsest, a literal overlapping of two or more separate sets of inscriptions, one carved on top of the other. The helicopter is not a depiction of a helicopter at all. It is the accidental composite shape formed by the remnants of the original hieroglyphs from Seti's time peeking out from underneath the new hieroglyphs carved for Ramesses. The helicopter's cockpit is part of one royal title. Its rotor blades are the legs and arms of another figure, and its tail is the result of a serpentine symbol intersecting with the corner of a carved rectangle. The other modern-looking vehicles are created through similar serendipitous overlaps, where curves, lines, and angles from different eras have merged to create entirely new and completely coincidental forms. This phenomenon is amplified by a powerful cognitive trick known as pareidolia, the human brain's innate tendency to find familiar patterns in random or ambiguous stimuli. We are hardwired to recognize faces in clouds and shapes in rock formations. When our modern brains, steeped in a world of technology, encounter these complex, overlapping shapes, they instantly lock onto the most recognizable patterns: a helicopter, a jet, a submarine. An ancient Egyptian looking at the same wall would have seen only a jumble of misplaced and conflicting hieroglyphs, a botched repair job. We, however, see the ghostly echoes of our own world, a Rorschach test in stone where our own technological anxieties and fantasies are projected onto the past. The enduring power of the Abydos carvings lies in this perfect storm of circumstances. They are a genuine archaeological mystery at first glance, found in a highly significant and authentic temple. The explanation of palimpsest, while completely logical to an epigrapher, is not immediately obvious to a layperson. It requires an understanding of hieroglyphic composition and Egyptian political practices that goes beyond a simple snapshot. This creates a fertile ground for speculation, where a simple, visually striking theory can often feel more satisfying than a complex technical one. The Abydos helicopter remains a focal point for alternative theories, not because the evidence supports them, but because it so perfectly captures our desire for the past to be more mysterious, more connected to our present than it perhaps really is. It stands as a powerful reminder that when we explore ancient sites, we are not just seeing what the builders intended us to see, but also the unintended consequences of time, erosion, and the endlessly pattern-seeking nature of the human mind. But let's pivot from the static mysteries carved into temple walls to a story of epic, dynamic movement across the globe's oceans. If you thought the age of exploration began with European names like Columbus or Magellan, prepare to have your historical compass reset. Decades before Columbus set sail in his 3 small ships, a Chinese admiral named Zheng, he was commanding a fleet so vast it would have dwarfed the entire Spanish Armada. Between 1405 and 1433, this legendary mariner led 7 monumental voyages from China into the heart of the Indian Ocean and beyond, not to conquer, but to project the Ming dynasty's power, prestige, and diplomacy on an unprecedented scale. The sheer physical scale of his flagship vessels, the legendary treasure ships, is almost difficult to process. According to Ming dynasty records, these behemoths were over 400 feet long. To put that into perspective, Columbus's flagship, the Santa Maria, was a mere 85 feet from stem to stern. Zheng, largest ships were wider than a modern Boeing 747 and had 9 towering masts carrying vast silk and cotton sails that could catch the slightest breeze. The fleets themselves were staggering maritime cities. A single voyage could comprise over 300 vessels of various types, including massive supply ships, water tankers, troop transports, and swift patrol boats. They carried a crew of over 27,000 men, including sailors, soldiers, interpreters, doctors, meteorologists, and even diplomats. This was not a tentative probe into the unknown. It was the deliberate, majestic movement of a floating empire, a display of logistical and nautical power that the world would not see again for centuries. Their navigation was as sophisticated as their shipbuilding. The Chinese mariners utilized a technology that was centuries ahead of its time, the magnetic compass. While Europeans were still cautiously coasting along shorelines, Zheng He's navigators used detailed star charts and compass bearings to traverse the open sea with confidence. They employed something called a Kaixingbin, a starboard, which was a navigational tool used to measure the altitude of stars above the horizon to determine their latitude. They also produced detailed maps and navigational guides known as Maokun maps, which charted vast distances with remarkable accuracy, listing stars, depths, and landmarks from China all the way to the coast of Africa. This was a system of wayfinding that combined celestial observation, magnetic direction, and meticulous record-keeping, a comprehensive approach to oceanic travel that European explorers would take another 100 years to develop. Now, this is where the historical narrative takes a fascinating and controversial turn. The official Ming records state that Zheng He's fleets reached as far as the eastern coast of Africa, trading for giraffes, zebras, and other exotic goods. But a compelling body of theories championed by historians like Gavin Menzies suggests his voyages did not stop there. The hypothesis is that parts of his fleet, either intentionally or blown off course, continued beyond the Cape of Good Hope and into the Atlantic, reaching the Americas decades before Columbus. Proponents of this theory point to various pieces of circumstantial evidence. They note apparent similarities between Ming-era artifacts and cultural practices found in pre-Columbian America. They analyze old maps, including the controversial Kangnido map from Korea, which seems to show a rough outline of the Americas and suggest this knowledge could have come from Chinese sources. There are even claims that Chinese shipwrecks and jade artifacts have been found along the Pacific coast of the Americas. The theory extends to the idea that Zheng He's fleet also charted the coast of Australia and perhaps even circumnavigated the globe, leaving behind clues that were later incorporated into European maps, potentially even influencing Columbus's own belief that he could reach Asia by sailing west. Of course, this radical rewriting of history is met with intense and often justified skepticism from mainstream academics. The primary criticism is a profound lack of direct archaeological evidence. If a Chinese fleet of 300 ships had reached the Americas, where is the irrefutable proof? Where are the sunken treasure ships in the Caribbean, the established trading posts on the coast of Brazil, or the definitive Chinese inscriptions on American rocks? Skeptics argue that the cultural parallels can be explained by independent development or later contact, and that the map evidence is often based on creative interpretation rather than rigorous cartographic analysis. They maintain that while Zheng He's voyages were an incredible achievement, their scope was confined to the Indian Ocean world, a realm that was already connected by ancient trade routes. Yet, the most haunting part of this story is not whether they reached America, but what happened next. After the seventh voyage, the entire enterprise was abruptly and completely shut down by the emperors who followed. The motivation was a dramatic shift in imperial policy. A new, inward-looking faction at court believed these extravagant voyages were a colossal waste of resources. They argued that China, the Middle Kingdom, was self-sufficient and had nothing to gain from dealing with foreign barbarians. The money was needed to fortify the northern borders against Mongol incursions. In a stunning act of historical self-sabotage, the great treasure ships were left to rot in their harbors. The meticulous logs and charts of the voyages were largely destroyed, and it was made a capital offense to even build a large ocean-going vessel. China deliberately turned its back on the sea. This decision invites one of history's most tantalizing what-if scenarios. What if China had continued its naval expansion? If Zheng He's voyages had been the beginning, not the end, of Chinese exploration, imagine a 15th century world where it was Chinese junks, not Spanish caravels, that first rounded the tip of South America. A world where Chinese, not European, languages, customs, and political systems became the dominant global force. The entire trajectory of the last 500 years, the Columbian Exchange, the rise of European colonialism, the distribution of world power could have been irrevocably altered. The deliberate choice to abandon the ocean stands as a sobering lesson in how the course of history can turn not on battles or discoveries, but on a single, inward-looking political decision. The ghost fleet of Zheng, he is a phantom limb of world history, a reminder of a path not taken where the balance of global influence could have tilted towards the east, leaving us to wonder how different our modern world might look. Deep in the tropical riverbeds and jungles of Costa Rica, another ancient mystery lies scattered across the landscape, one that trades intricate gears and carved hieroglyphs for a form of profound, minimalist perfection. Imagine stumbling upon a stone sphere so perfectly round, so impossibly smooth, that it looks as if it were turned on a modern industrial lathe. Now imagine not just one, but hundreds of them, ranging in size from a child's plaything to colossal orbs over 8 feet in diameter and weighing more than 15 tons. These are the stone spheres of Costa Rica, and since their modern rediscovery in the 1930s, when the United Fruit Company was clearing land for banana plantations, they have presented archaeologists with a puzzle that is deceptively simple in its geometry but deeply complex in its implications. The first layer of this enigma is the sheer precision of their craftsmanship. Carved from a tough, granular igneous rock called granodiorite, these spheres are not merely roundish boulders. Scientific analysis has revealed that many of them display a sphericity that deviates by less than 2% from a perfect geometric sphere. Their surfaces are often remarkably smooth, with a consistent texture that speaks to an extensive and careful finishing process. This level of accuracy, achieved on such a massive scale and with such resilient material, is an engineering feat that demands an explanation. The Diquis culture, which flourished in the region from around 700 AD until just before the Spanish arrival, is credited with their creation, yet they possessed no metal tools harder than the stone they were shaping. They had no written language, no wheeled vehicles, and no draft animals to aid in this monumental task. So how did they do it? The process likely began with identifying a suitable large boulder in a riverbed or quarry. The initial shaping is thought to have involved a technique of controlled heating and cooling. By building fires against the rock and then rapidly cooling the heated surface with water, the stonemasons could create thermal stress cracks, causing large flakes to spall off. This would have allowed them to rough out a spherical form from the raw block. From there, the painstaking work of pecking, grinding, and polishing began. Using hammerstones made of an even harder material like quartz or another piece of granodiorite, they would have systematically pounded the surface, gradually crushing the crystalline grains. This would have been followed by endless hours of grinding with sand and water, using leather or coarse textiles to slowly abrade the surface down to its final, stunning smoothness. The entire endeavor for a single large sphere would have represented an immense investment of time and coordinated labor, a project spanning years or even generations. The mystery only deepens when we consider their transportation and placement. Many of the largest spheres were found miles from the nearest known source of their stone. How were these multi-ton granite balls moved through dense jungle and across rugged terrain? The most plausible theory involves a combination of log rollers, rope systems, and immense human power. It's possible they were rolled on a cradle of logs, or perhaps levered onto wooden sledges and pulled by large teams of people. Some researchers have suggested they might have been transported on rafts along rivers, a daunting proposition given their tremendous weight. Their final placement was clearly deliberate. Many were arranged in complex geometric patterns such as straight lines, triangles, and wide circles, often on top of artificial mounds or in prominent plaza areas. This was not random disposal. It was a purposeful and sophisticated act of landscape architecture. This deliberate placement fuels the most compelling question of all: what was their purpose? Without any written records from the dikwis themselves, archaeologists have had to piece together theories from the sphere's contexts and alignments. One prominent idea is that they functioned as astronomical markers. Some of the alignments appear to point toward significant celestial events, such as the rising and setting of the sun during the solstices or equinoxes. In this view, the spheres could have been a kind of permanent terrestrial planetarium, anchoring the dikwis' worldview to the cyclical movements of the heavens and helping to regulate their agricultural calendar. Another equally compelling theory posits a deep social and political function. In many ancient societies, the ability to marshal vast labor for non-utilitarian projects was a direct demonstration of power and social cohesion. The creation and placement of these spheres may have been a way for emerging chiefs or clan leaders to showcase their authority, commanding the labor needed to produce these immutable symbols of their power. They could have served as territorial markers, delineating the lands of different communities, or as monuments at the graves of important leaders, their perfect forms symbolizing eternal power and cosmic order. The very act of their creation, requiring the coordination of skilled artisans and laborers over long periods, would have reinforced social hierarchies and collective identity, making the spheres as much a social technology as a sculptural one. The true wonder of the Costa Rican stone spheres, therefore, lies not in a single answer, but in the convergence of multiple forms of ancient genius. They represent a mastery of materials and geometry, a profound understanding of empirical stoneworking techniques developed through generations of trial and error. They speak to a sophisticated social organization capable of planning and executing long-term, labor-intensive projects, and they hint at a complex cosmological understanding where the perfect, eternal shape of the sphere served as a bridge between the human community, the political hierarchy, and the cosmos itself. Unlike many artifacts that have been looted or moved, the greatest mystery these silent orbs guard may be the very nature of the society that felt compelled to reshape their world into a form of such perfect, enduring harmony. While we marvel at the physical artifacts and machines left behind by ancient civilizations, some of the most breathtaking leaps of intellect left no physical trace at all. They existed solely as ideas, born from the power of pure reason in a world without microscopes or particle accelerators. To find one of the most stunning examples of this, we must travel to the world of ancient Greece in the 5th century BC, to the minds of philosophers like Leucippus and his student Democritus. In an age where many explain the world through the capricious wills of gods or the four classic elements of earth, air, fire, and water, these thinkers proposed a theory so radical, so abstract, that it would take over 2 millennia for science to catch up. They imagined that if you were to take any substance, a piece of wood, a drop of water, the air itself, and cut it in half, and then cut that half in half, and continue this process again and again, you would eventually reach a point where it could be cut no further. They called this fundamental, indivisible building block of all reality the atomos, meaning uncuttable or indivisible. This was the birth of atomic theory, a philosophical concept that stands as one of the most prescient and profound thought experiments in all of human history. The methodology behind this conceptual leap was as revolutionary as the idea itself. Democritus and his school were part of a philosophical tradition that valued logic and rational deduction above all else. They didn't arrive at the atom by conducting experiments in a lab. They got there by thinking deeply about the nature of change and the void. They observed that the world is in a constant state of flux. Wood burns and turns to ash and smoke. Water evaporates and becomes air. Grapes ferment and become wine. To explain this perpetual transformation, they reasoned there must be some permanent, underlying reality that itself does not change. They also made a crucial postulation that was highly controversial at the time: the existence of the void or empty space. They argued that for motion and change to be possible, there must be emptiness for things to move into. From these two foundational principles, permanence and the void, they constructed their entire theory. They proposed that the universe was composed of nothing but an infinite number of these uncuttable atomos and an infinite void. Everything we see, feel, and are is merely different configurations of these eternal, indestructible particles moving through the emptiness. Their description of these theoretical particles is what makes their achievement so chillingly accurate. Democritus proposed that the atoms themselves were solid, homogeneous, and varied only in a few fundamental properties: their shape, their size, and their arrangement. He suggested that the sensation of taste, for example, arose from the shapes of the atoms involved. Sharp, angular atoms might correspond to a sour or bitter taste, while round, smooth atoms might create a sweet sensation. The property of hardness was explained by atoms that were hooked or intertwined, holding fast to one another, while liquids were composed of smooth, slippery atoms that slid easily past each other. The soul itself, in his view, was made of particularly fine, spherical atoms that were the most mobile and animated. This was a completely mechanical and materialistic view of the universe, one that sought to explain the immense diversity and complexity of the sensory world through the interactions of simple, unchanging physical building blocks. The chasm between this ancient philosophical speculation and the hard, empirical science of the modern atom is, of course, vast, yet the parallels are undeniably eerie. It took until the early 19th century for the English chemist John Dalton to formally propose a scientific atomic theory based on the quantitative study of chemical reactions. And even then, the core conceptual inheritance from Democritus was profound. The idea of indestructible atoms as the fundamental units of elements combining in fixed ratios to form compounds is the direct descendant of the atomos philosophy. The modern atom, with its nucleus of protons and neutrons and its cloud of electrons, is of course far more complex than the solid, homogeneous particle imagined by the Greeks. We know atoms are not truly indivisible but can be split in nuclear reactions. Yet, in the realm of chemistry, for the very reactions Democritus was trying to explain, the atom behaves as a fundamental, uncuttable unit. His core intuition that the apparent continuity of matter is an illusion, and that at its heart lies a particulate, granular reality was resoundingly correct. The true significance of this story is not that Democritus somehow guessed the exact details of subatomic physics, but that the human mind, armed with nothing more than relentless logic and profound curiosity, was able to correctly deduce a fundamental truth about the architecture of reality that was completely beyond the reach of its senses. This was abstract thought operating at its highest level, a testament to the power of reason to penetrate the deepest secrets of the natural world. It also serves as a humbling lesson on the nature of scientific progress. This brilliant idea, which could have set science on a different path, was largely overshadowed by the theories of Aristotle, who rejected the atomic hypothesis in favor of the continuous elements. Aristotle's immense influence ensured that atomic theory lay dormant for centuries, a forgotten seed of genius waiting for the right conditions to sprout. The journey of the atom, from a philosophical speculation in ancient Greece to a cornerstone of modern science, reminds us that the most powerful technologies are not always made of gears or stone, but can be forged from the raw material of a single, brilliant idea, capable of echoing across millennia. Now, let us soar high above the arid plateaus of southern Peru, where the desert floor itself becomes an immense canvas for one of the world's most magnificent and enduring mysteries. Etched into the dark, iron oxide-coated pebbles of the Nazca Desert are hundreds of enormous geoglyphs, lines, shapes, and figures so vast they defy comprehension from the ground. To truly witness them, you must take to the sky. From the vantage point of an aircraft, the landscape transforms. A colossal monkey with a spiraling tail emerges. A hummingbird with a beak as long as a football field hovers in flight. and a spider with legs stretching for dozens of yards appears ready to scuttle across the plain. These are the Nazca Lines, a gallery of ancient art on a monumental scale, created by a people who could never have seen their own work in its entirety, a paradox that lies at the very heart of their enigmatic power. The process of their creation speaks to an astonishing communal effort and a profound understanding of the desert environment. The Nazca people, flourishing between 200 BC and 600 AD, did not build these lines with massive stones. They performed a kind of terrestrial subtraction. The desert pavement here is covered in a layer of dark, manganese-rich pebbles that have oxidized to a deep rust color over millennia. Beneath this dark surface lies a lighter-colored, sandy subsoil. The artists created their designs by meticulously removing the top layer of these dark stones, exposing the bright, creamy earth underneath. The contrast between the dark border and the light interior creates a striking visual line that has been preserved for nearly 2,000 years. This was not a haphazard scraping. They organized large teams of workers who carefully cleared the stones, piling them along the edges of the figures to create defined berms. The sheer scale of this labor is staggering. Some of the straight lines run for miles across the desert, maintaining a razor-straight trajectory over hills and valleys without deviating. The largest single figure, a pelican, is nearly 900 feet long, while a lizard stretches for over 600 feet. This was a generations-long project, a sustained cultural obsession with reshaping the very skin of the earth. This immediately raises the captivating question of execution. How did a culture without the ability to fly, without sophisticated optical instruments, manage to create such precise, large-scale designs that only make sense from hundreds of feet in the air? The answer reveals a mastery of low-tech but highly effective surveying techniques. The prevailing theory, supported by experimental archaeology, suggests they used a system of scaling up from small-scale models. An artist or priest could have first designed the figure on a small sheet of cloth or a prepared patch of ground. This design was then broken down into a series of coordinate points. To transfer it to the grand scale, they likely erected a central pole at a key point on the desert floor. From this pole, they would have measured out radial lines using ropes of a fixed length, perhaps made from llama hide, marking the critical points of the design: the tip of a wing, the curve of a tail. By clearing the stones between these pre-plotted points, teams of workers could create the massive figures section by section, never needing to see the whole. For the immensely long, straight lines, they may have used a series of aligned stakes, sighting along them to maintain a perfect bearing across the undulating terrain. This was applied mathematics and geometry on a breathtaking scale, a testament to an empirical understanding of proportion and measurement that allowed them to overcome the limitations of their own perspective. The true, haunting mystery, of course, is not how they did it, but why. What powerful impulse drove the Nazca people to expend such colossal effort on creations they themselves could never fully behold? The theories surrounding their purpose are as vast and varied as the lines themselves, each one offering a different window into the Nazca worldview. One of the earliest and most persistent ideas is that the lines functioned as a giant astronomical calendar, proposed by historian Paul Kosok, who famously called the Nazca Desert the world's largest astronomy book. This theory suggests the lines pointed to key positions of the sun, moon, and stars on the horizon, marking solstices, equinoxes, and other significant celestial events. This would have been critically important for an agricultural society, dictating the timing for planting and harvesting in an unforgiving climate. However, while some lines do align with celestial bodies, subsequent statistical analysis has shown that no more alignments exist than one would expect by random chance, casting doubt on this as a comprehensive explanation. A more widely accepted theory today views the lines as sacred pathways integral to religious rituals, closely tied to the desperate need for water. The Nazca region is one of the driest places on Earth, where rain might fall for only a few minutes each year. Survival depended on accessing underground aquifers. Many of the longest lines lead directly from the mountains to sources of water, and the trapezoids and triangles often point toward mountains that were sources of precious runoff. In this interpretation, the geoglyphs were not meant to be seen by gods in the sky, but to be walked upon by priests and pilgrims. The act of processing along these lines, particularly the wide trapezoids and rectangles, may have been a form of ceremonial walking, a ritual prayer for life-giving water. The animal figures, many of which are associated with water or fertility in Andean cosmology, the hummingbird, the whale, the monkey could have been spiritual conduits, offerings to the deities who controlled the rain. The lines, in this sense, were a form of sympathetic magic, a way of drawing the essence of water and fertility directly into the landscape. This leads to the most captivating and controversial theory of all, popularized by writer Erich von Däniken, that the lines were landing strips or signals for extraterrestrial visitors. Proponents of this ancient astronaut hypothesis argue that the perfect straightness and immense scale of the lines, combined with the fact they are only visible from the air, is clear evidence that they were intended for sky gods who traveled in spacecraft. They point to certain figures like the so-called astronaut, a large humanoid figure with what appears to be a round helmet, as proof of this otherworldly contact. While this idea has captured the public imagination, it is almost universally dismissed by archaeologists. The astronaut is more likely a shaman or a deity, and the line's construction is fully explainable through known human methods. This theory, however fantastical, succeeds in highlighting the profound sense of awe the lines inspire, a feeling that their true purpose might be just beyond our grasp. Ultimately, the greatest wonder of the Nazca lines may lie in their incredible endurance. For 2,000 years, they have resisted being erased by wind and the occasional rain. The very climate that made water so precious for the Nazca people is what preserved their art. The lack of significant rainfall means there is little erosion, and the unique composition of the desert floor plays a crucial role. The exposed, light-colored sand is hardened by a process where morning mist and dew cause a chemical reaction with the salts in the soil, forming a protective, cement-like crust that prevents the lines from being scoured away by the wind. They are a perfect collaboration between human intention and a unique geological environment. The Nazca lines, therefore, are more than just a collection of ancient drawings. They are a permanent inscription of a culture's deepest anxieties and highest aspirations, a sprawling, beautiful question mark written across 450 square kilometers of desert, challenging us to understand the profound connection between a people, their environment, and the cosmos they sought to influence. Now, imagine the height of a scorching summer in the heart of the Persian Empire, centuries before the Common Era. The sun beats down relentlessly on the arid landscape, and the very air shimmers with heat. Yet, in the midst of this desert, a traveler or a local ruler could enjoy a profound luxury: a bowl of chilled fruit, a cool drink, or even a scoop of frozen dessert. This wasn't magic, it was the result of brilliant, sustainable engineering in the form of a structure known as the yakchul, which translates simply to ice pit. These ancient refrigerators, often towering domes of sand-colored mud brick, allowed Persians to defy their climate and preserve ice and food throughout the blistering heat of the year, achieving a level of comfort that was unimaginable elsewhere in the ancient world. The ingenuity of the yakchul lies in its holistic design, a system that worked in perfect harmony with its environment rather than fighting against it. These structures were typically composed of 3 integrated components, each playing a critical role. First was the massive, domed structure itself, which could be up to 60 feet high. This dome was not just for show, its shape and material were scientifically chosen. It was constructed from a special heat-resistant mortar called saruj, a mixture of sand, clay, egg whites, lime, goat hair, and ash that was not only an exceptional insulator but also remarkably strong. This thick, earthen shell acted as a barrier, keeping the intense external heat from penetrating the interior space. Beneath this dome lay a vast underground storage pit, often descending deep into the earth, where the cooler subterranean temperatures provided a natural baseline for preservation. The second key element was the source of the ice itself, which often involved a clever manipulation of water and the cold desert nights. In many cases, this was achieved through a network of qanats, which were gently sloping underground aqueducts that channeled water from mountain aquifers to the parched plains and cities. This water was then directed to shallow, shaded pond areas adjacent to the Yakchul. During the clear, cold winter nights when desert temperatures can plummet dramatically, this water would freeze. Workers would then harvest the ice, breaking it into manageable chunks. Other methods involved simply channeling mountain runoff that had frozen during the night into the storage pits. This process of harvesting natural ice, often in a desert environment, is a testament to the Persians' acute understanding of their local climate patterns. The true genius of the system, however, was its ability to maintain these freezing temperatures all through the summer, and this is where the third component, the wind catcher, came into play. A wind catcher, or bajir, is a traditional Persian architectural structure that functions as a natural air conditioning system. It is a tower capped with openings oriented to catch the prevailing wind. As the wind is funneled down the tower, it is often directed over an indoor pool of water or down into the subterranean chamber of the Yakchul itself. This process cools the air through evaporation and by bringing it into contact with the cold mass of the stored ice and the earth-cooled walls. The structure also acted as a reverse chimney. The hot air inside the dome, being lighter, would naturally rise and escape through openings at the top, creating a constant, passive circulation that kept the interior space dry and chilled. This was a self-regulating system that required no moving parts and consumed no energy beyond the initial labor of its construction. The impact of this technology on Persian society and culture was profound. It wasn't just about preserving basic foodstuffs, it enabled a level of culinary sophistication and luxury that was extraordinary for its time. The Persians are credited with creating one of the earliest forms of ice cream, a delicacy made from frozen rose water, vermicelli, and fruits sweetened with honey or sugar. They could enjoy chilled wines and sherbets and preserve dairy products and meat for extended periods, which was a critical advantage for both daily life and long-distance trade. This command over cold gave them a quality of life and a gastronomic culture that stood in stark contrast to much of the world. While the Persian elite were savoring frozen desserts in the desert, many European societies would have to wait until the 17th or 18th centuries with the importation of ice houses from the East to experience similar luxuries on any significant scale. The Yakchul stands as a monumental achievement in passive cooling, a perfect marriage of architecture, hydrology, and climatology that provided sustainable comfort and luxury in one of the most challenging environments on Earth. From the silent, sun-baked deserts of Peru, we now venture into the cool, hushed scriptorium of a medieval monastery where a different kind of colossal creation was taking shape, one not carved into the earth but inscribed on the skin of animals. Tucked away in the National Library of Sweden is a book so massive and heavy that it takes two people to lift it. This is the Codex Gigas, known to history as the Devil's Bible, a sprawling 13th century manuscript that is as much a monument to human endurance as it is a repository of sacred texts. Its very dimensions are staggering. The wooden binding measures 3 feet in length and nearly 20 inches in width, and the entire volume weighs as much as 165 pounds. Composed of over 300 sheets of vellum, which required the skins of an estimated 160 donkeys to produce, it contains the complete Latin Vulgate Bible, along with a host of other crucial historical, medical, and philosophical works from the medieval world, including the works of Josephus, a chronicle of Bohemia, and medical cures. But it is not the book's size or its comprehensive contents that have cemented its legendary status for centuries. It is the chilling, full-page illustration that stares out from page 290, a vivid, powerful depiction of the devil himself, which gives this monumental work its infamous name. The legend that clings to the Codex Gigas is as compelling as the tome is large. According to the lore that began circulating not long after its creation, the manuscript was the work of a single Benedictine monk who had broken his sacred vows and was sentenced to be walled up alive as punishment. In his desperation, the monk promised he would create a book that would bring everlasting glory to his monastery, a volume containing all human knowledge, and he vowed to complete it in a single night. As the sun set and the task proved impossible, the monk prayed not to God but to the fallen archangel Lucifer, offering his soul in exchange for completion of the work. The legend says the devil himself appeared, finished the manuscript, and in gratitude, the monk added the portrait of his infernal benefactor as a tribute. This story, while a fantastic piece of folklore, speaks directly to the sheer, superhuman scale of the endeavor, an achievement so grand that for centuries, people could only explain it through a pact with dark, supernatural forces. When modern scholars subjected the Codex to rigorous analysis, what they discovered was both more mundane and, in its own way, even more extraordinary than the devilish legend. Through meticulous examination of the handwriting, letter forms, and ink composition across the entire manuscript, researchers reached a startling conclusion. The vast majority of the text appears to be the work of a single, incredibly disciplined scribe. The script is remarkably consistent from the first page to the last, showing none of the variations in style, pressure, or penmanship that would naturally occur if multiple scribes had worked on it over many years. This finding transforms the creation of the Codex Gigas from a collaborative project into a feat of almost unimaginable personal dedication. One person, one hand, is responsible for every single word in that 165-pound book. Consider the physical and mental toll such an undertaking would have required. This was not a simple act of copying. The scribe had to prepare the vellum pages, rule them with straight lines for writing, and then spend years bent over a desk, meticulously forming each letter with a quill and ink that he likely made himself. The text is not merely written, it is lavishly illuminated with elaborate initials, intricate flourishes, and vibrant red, blue, green, and yellow pigments that had to be carefully sourced and applied. To produce such a vast volume alone, historians estimate the scribe would have needed to work for upwards of 20 or even 30 years, laboring for as many as 12 hours a day every single day. The mental fortitude to maintain such consistency, to avoid catastrophic errors over decades of work, and to simply keep going in the face of such a monumental task is a testament to a level of devotion and focus that borders on the superhuman. It was a marathon of the spirit, a lifetime of quiet, painstaking work dedicated to creating a single, perfect masterpiece. So, who was this unknown scribe, and why did he undertake this solitary, lifelong vow? While his name is lost to history, the context of the manuscript offers clues. The inclusion of specific local historical texts points to the monastery of Podlažis in Bohemia, modern-day Czech Republic, as its likely place of origin. This was a region often rocked by political and religious conflict. One compelling theory is that the monastery commissioned or a monk undertook this project as a form of penance or as a desperate act of diplomacy. A book of this magnitude and beauty would have been an object of immense prestige and value, a treasure that could be used to curry favor with a powerful patron, to settle a debt, or to restore a monastery's tarnished reputation. The terrifying image of the devil, therefore, might not be a tribute but a stark medieval warning, a vivid depiction of the hell that awaited sinners, placed purposefully opposite a magnificent illustration of the heavenly city on the facing page, creating a powerful visual sermon on the eternal choice between salvation and damnation. The Codex Gigas, therefore, transcends its label as the Devil's Bible. It is a multifaceted artifact, a library in a single volume, a masterpiece of calligraphic art, and above all, a permanent monument to the power of a single human will, a testament to what one person can achieve with a lifetime of unwavering dedication, leaving behind a legacy so immense that its creation seemed to later generations to be the work of something other than human hands. Yet, for all the mechanical and architectural genius we have witnessed, some of the most profound innovations of the ancient world were not forged in metal or carved in stone, but built within the very fabric of society itself. Let us travel to the sun-baked hills of Attica, to the city-state of Athens in the 5th century BC, where an experiment in human governance was unfolding that would echo for millennia. While the pharaohs of Egypt were hailed as living gods and the Persian king of kings wielded absolute power, the Athenians were crafting a system where the source of authority was not a throne, but the collective will of the people. This was democracy from the Greek demokratia, meaning rule by the people, and its introduction was a political and social earthquake of a magnitude the world had never seen. The machinery of this system was both radical and remarkably sophisticated, centered on 3 core institutions that empowered the citizen body. The supreme authority was the assembly, or ecclesia, a massive, open-air meeting held on a hillside called the Pnyx. Any of the approximately 40,000 qualified male citizens over the age of 18 could attend, debate, and vote directly on the laws and policies of the state. Picture a crowd of thousands not just passively listening, but actively shouting arguments, raising hands, and deciding on matters of war and peace, foreign alliances, and public finances. There were no professional politicians. The government was the people in session. To manage the day-to-day affairs of the city, there was the Council of 500, or Boule. Its members were not elected but chosen by lot from the citizen rolls, a method designed to prevent the rise of a corrupt political class and to ensure that every ordinary citizen had a direct, rotating turn in governance. These 500 men, serving for 1 year, prepared the agenda for the assembly, oversaw the city's administration, and coordinated the work of various committees. Finally, there were the people's courts, where citizen juries, often comprising hundreds or even thousands of individuals selected by lot, would hear legal cases. There were no judges in the modern sense. The jury was both the finder of fact and the interpreter of the law, with prosecutors and defendants arguing their own cases directly before their peers. This system of mass participation, from legislation to administration to justice, created a level of civic engagement and personal investment in the state that was utterly unprecedented. To truly grasp the revolutionary nature of this innovation, we must contrast it with the political realities that surrounded it. The ancient world was overwhelmingly a landscape of autocracy. In the vast Persian Empire to the east, the monarch's word was law, his authority believed to be divinely sanctioned. In Egypt, the pharaoh was a god-king, the absolute intermediary between the divine and mortal realms. Even in other Greek city-states like Sparta, power was concentrated in the hands of a small, hereditary oligarchy of warrior citizens or a single, powerful king. In this context, the Athenian assertion that ultimate authority resided in the collective body of ordinary male citizens was a breathtakingly bold declaration of human potential. It asserted that people were capable of governing themselves through reasoned debate and collective decision-making, that they did not need a god-king or a despot to tell them how to live. This was a technology of the mind and the spirit, an operating system for a society built on the radical premise of shared power and civic equality before the law, known as isonomia. Of course, we must acknowledge that this brilliant system was deeply imperfect and limited by our modern standards. The people in this democracy constituted a minority of the actual population. Citizenship was an exclusive club denied to women, slaves who made up a significant portion of Athenian society, and foreign residents, known as metics. This meant that while the principle was revolutionary, its practice excluded the vast majority of people who lived and worked within the Athenian state. Furthermore, the system was vulnerable to the passions and prejudices of the crowd, a flaw famously demonstrated by the trial and execution of the philosopher Socrates, who was condemned to death by a jury of his fellow citizens for allegedly corrupting the youth and impiety. The direct, unfiltered nature of the democracy could sometimes lead to impulsive and disastrous decisions, such as the disastrous Sicilian expedition during the Peloponnesian War, a military adventure voted for by the assembly that ultimately crippled Athenian power. Yet, despite its flaws and its eventual collapse, the foundational principles of Athenian democracy proved to be indestructible seeds. The core ideas that citizens have a right to participate in their own governance, that leaders should be accountable to the law, and that a state is strongest when its people have a direct stake in its success, refuse to die. These concepts were studied by Roman philosophers, rediscovered during the Renaissance, and passionately embraced by Enlightenment thinkers like John Locke, Montesquieu, and Thomas Jefferson. They saw in Athens not a perfect model to be copied, but a powerful proof of concept. The American founding fathers, while creating a representative republic rather than a direct democracy, were directly inspired by the Athenian experiment in self-rule, adapting its principles of popular sovereignty and civic duty for a modern, large-scale nation. The long, often turbulent journey of democratic governance, from the assemblies of ancient Greece to the constitutional frameworks of today, all trace their intellectual lineage back to that singular, radical moment when a society of ordinary people decided that they, and not a king, were the ultimate authors of their own destiny. This was not just a political system, it was a declaration of human potential, a revolutionary innovation that continues to shape our world in profound and enduring ways. From the abstract realms of political philosophy and the sprawling artistry of the Nazca Desert, we now turn to a monument where architectural ambition meets a precision so absolute it seems to belong to a different age altogether. Standing on the Giza Plateau, the Great Pyramid does not just impress with its sheer mass, it humbles with its exactitude. Constructed around 2560 BC for the pharaoh Khufu, this colossal structure is a masterpiece of geodetic and astronomical engineering, a mountain of stone carved with an accuracy that would challenge modern builders even with our advanced technology. The most fundamental demonstration of this precision lies in its breathtaking orientation to the cosmos. The four sides of its base are aligned to the four cardinal directions, north, south, east, and west, with an error so minute it feels impossible. The average deviation from true north across its four sides is a mere 3/60ths of a single degree. To put that in perspective, that is an accuracy of 0.05%. This is not merely close, it is a level of perfection that seems to defy the presumed capabilities of a society working with simple copper tools and rope. Achieving this alignment required a profound and sophisticated understanding of the night sky. The most plausible method, supported by many Egyptologists, involves tracking the circumpolar stars. Unlike the sun, which rises and sets at shifting points along the horizon, certain stars, like those in the Big Dipper or the constellation Draco, circle a fixed point in the sky near the North Star. Ancient Egyptian astronomers could have used a vertical sighting rod or a plumb bob within a confined, darkened corridor to carefully monitor the transit of a specific circumpolar star. By marking the points on the horizon where the star reached its furthest eastern and western extremes during its nightly circuit, they could bisect the angle between these 2 points to find a true, unwavering north-south line with astonishing accuracy. This was not a one-night operation. It would have required meticulous observation over many nights, perhaps even an entire cycle of the seasons, to refine the line and eliminate any observational error. This method reveals a civilization that did not just gaze at the stars with wonder, but engaged with them as a dynamic mechanical clock, using their predictable motions to anchor their most sacred earthly creations to the eternal fabric of the cosmos. But the pyramid's genius extends from the heavens down to the very ground it rests upon. The base of the Great Pyramid is not just oriented correctly, it is also a nearly perfect square. The difference in length between its longest and shortest sides is less than 2 inches across a base that is over 750 feet long on each side. This represents a variation of less than 0.01%. To accomplish this, the builders had to first level the entire 13-acre bedrock foundation to a flat plain. Using a network of water-filled trenches cut into the rock to create a consistent horizon line, they could have painstakingly measured down to a uniform depth across the entire site, chiseling the limestone base to an almost perfectly level surface. The error across the entire area is a mere fraction of an inch, a feat of large-scale leveling that is difficult to comprehend. Ensuring the perfect right angles at the corners of this massive square would have been another monumental task, likely achieved through the practical application of the Pythagorean theorem, centuries before Pythagoras was born. By creating a triangle with sides in a 3:4:5 ratio using knotted ropes, they could have guaranteed a perfect 90-degree angle, carefully checking and rechecking their work across distances that would have stretched their surveying cords to the limit. The implications of this precision are staggering. It speaks to a command of project management, quality control, and applied mathematics that was without parallel in the ancient world. This was not the work of brute force alone. It was the product of a highly organized, literate society of master surveyors, architects, and astronomers who could conceive of a project on a grand scale and then execute it with micrometer-level accuracy. The pyramid's alignment was not merely for show. It was deeply symbolic, connecting the pharaoh, a divine ruler, to the eternal and unchanging order of the universe. His tomb was a machine for resurrection, and its perfect orientation ensured his spirit could correctly navigate the heavens to join the gods. The Great Pyramid, therefore, is far more than a tomb. It is a permanent testament to a civilization that achieved a harmonious synthesis of spiritual belief and empirical science, creating a benchmark of precision that would not be surpassed for thousands of years and continues to stand as a silent, formidable challenge to our understanding of our own past. Yet, while the Great Pyramid's precision was directed toward a single, eternal monument, another civilization was achieving a different kind of permanence, one that sprawled dynamically across 3 continents, stitching an empire together with lines of stone and ambition. Imagine the vast expanse of the Roman Empire at its peak, from the rainy highlands of Britain to the sun-scorched sands of Egypt. To move an army, a tax collector, or an imperial decree across such unimaginable distances required more than just political will. It required a physical network of unprecedented scale and durability. This was the triumph of Roman roads, an infrastructure project so colossal and so brilliantly engineered that its bones still support the transport of the modern world 2,000 years later. The most immediately striking feature of these roads was their breathtaking straightness. When you see a Roman road cutting across the English countryside or the Italian peninsula, it often disregards gentle hills and shallow valleys, marching directly from one point to the next. This was not an aesthetic choice, it was a strategic and logistical imperative. A straight road is the shortest possible path, allowing for the fastest movement of troops, the most efficient transport of goods, and the quickest delivery of messages. To achieve this geometric perfection across such varied and often hostile terrain required a mastery of surveying that was generations ahead of its time. The Romans were, in essence, the master cartographers of the land itself. Their secret weapons were a suite of ingenious yet elegantly simple surveying instruments. The workhorse of the Roman surveyor, or agrimensor, was the groma. This device consisted of a vertical staff with a horizontal crossarm from which plumb bobs were suspended on each of its four arms. By sighting along the lines created by these weighted strings, a surveyor could establish perfect right angles and dead straight lines across great distances. A team would set up the groma, align one pair of plumb bobs with a distant marker, and then use the perpendicular arms to stake out the road's width and direction. For leveling, they employed the chorobates, a sophisticated tool that was essentially a long, wooden frame with a central groove filled with water. By observing the water level in this groove, or by using plumb lines attached to the frame, they could determine a true horizontal plane with remarkable accuracy, ensuring their roads had the consistent, gentle gradient needed for drainage and ease of travel. With these tools, they could project a straight line from one horizon to the next, conquering the landscape's irregularities with unyielding geometry. But the true genius of the Roman road lay beneath the surface in a multi-layered construction technique that was as meticulous as it was robust. Building a major Roman road was a surgical process. First, surveyors and laborers would dig a trench or fossa down to stable ground, often as deep as 3 or 4 feet. This foundation was then filled with a layer of large, flat stones, the stotumen, which provided a solid base and facilitated drainage. On top of this, a second layer of smaller stones mixed with lime, the rudus, was compacted to create a firm, stable core. The third layer, the nucleus, was a mixture of gravel, sand, and clay, painstakingly rammed down to form a smooth, cambered surface that would shed rainwater to the sides. Finally, the crowning glory was the summum dorsum, the wearing surface made of tightly fitted, interlocking flint or volcanic stone pavers set in a bed of sand or mortar. This carefully engineered sandwich was flexible yet strong, able to absorb the stress of countless marching legions and heavy carts without cracking or subsiding. The road was also crowned, meaning it was higher in the center than at the edges, with drainage ditches running alongside to channel water away, protecting the structure from the destructive power of frost and erosion. This was not mere path-making, it was a form of civil engineering that considered hydrology, load-bearing physics, and long-term durability. The result of this immense effort was a network that truly bound the empire together. At its zenith, over 250,000 miles of these paved highways stretched across Europe, North Africa, and the Middle East. They were the arteries of empire along which legions could march 25 miles a day, and the imperial courier service, the cursus publicus, could relay messages from the Rhine to Rome in a matter of weeks. This infrastructure enabled not just military control, but economic and cultural cohesion. Goods from across the known world could flow to the capital, ideas and technologies could spread, and a shared Roman identity could take root in provinces thousands of miles apart. The famous phrase, "all roads lead to Rome," was not just a metaphor, it was a literal statement of a centralized, connected world. Perhaps the most powerful testament to their engineering is that these roads never truly vanished. In countless parts of Europe, modern asphalt highways still follow the exact, unerringly straight path laid down by Roman surveyors 2 millennia ago. The Via Appia, the Queen of Roads, still has its original stone blocks in places. In York, England, the main street lies directly atop a Roman road, and the foundations of Roman bridges still support traffic today. They built not for their century, but for millennia, creating a skeleton of stone so durable that the modern world simply paved over it and continued the journey. In an age of crumbling infrastructure, the silent, enduring presence of a Roman road is a profound lesson in building for the future, a permanent reminder that the true measure of a civilization's greatness is often found not in its grandest monuments, but in the solid, reliable ground beneath our feet. Now, let us peer inside that beautiful bronze urn and unlock the mechanical secret that made Zhang Heng's earthquake detector so revolutionary. While the original internal workings were lost to time, modern engineers and seismologists have proposed a compelling reconstruction based on the device's described behavior. The most widely accepted theory centers on a brilliant yet elegantly simple principle, the inverted pendulum. Imagine a heavy mass, likely a solid metal rod or weight, suspended loosely from the top of the vessel, hanging down into its center. This pendulum is the heart of the machine, its sensitive inertial core. Under normal, calm conditions, it hangs straight down, perfectly still. But when the primary seismic waves from a distant earthquake ripple through the ground and reach the device, they impart a subtle, almost imperceptible horizontal force. This force causes the heavy pendulum to swing, not in a random jiggle, but with a distinct preference toward the direction from which the seismic energy originated. The true ingenuity lies in how this subtle swing was translated into an unambiguous signal. Arranged around the base of the pendulum, at the 8 cardinal directions corresponding to the 8 dragon heads, were a series of trigger mechanisms. The most plausible design involves a set of delicate levers or catches, each one connected to a release mechanism for a specific dragon. As the pendulum swings toward the source of the quake, it would bump into or trip only one of these levers, the one aligned with the direction of the force. This action would act like the trigger of a mousetrap, causing that dragon's jaws to spring open and release the bronze ball into the waiting frog's mouth below. This system is a masterpiece of information filtering. It was designed to ignore the general shaking and minor tremors that would cause the pendulum to jiggle in all directions. It only responded to a sustained, directional push strong enough to definitively engage a single, specific release catch. This ensured that a ball dropping was a reliable event, signaling not just local vibration, but a genuine seismic wave from a particular bearing. A fascinating debate persists among historians of technology regarding the complexity of this internal triggering system. One camp argues for ultimate simplicity, proposing a direct mechanical linkage. In this model, the swinging pendulum itself would physically strike a lever connected to a latch, directly releasing the ball. This elegant design requires minimal moving parts and is incredibly robust. However, another school of thought suggests a more intricate arrangement, possibly involving a system of geared connections. This would allow for a mechanical advantage, where a small swing of the pendulum could be amplified to provide the force needed to reliably open the dragon's maw, which might have been held shut by a fairly stiff spring or latch. While no gears have been mentioned in historical accounts, the existence of the Antikythera Mechanism proves that the Han Dynasty's contemporaries were fully capable of such sophisticated mechanics. Whether through a simple lever or a more complex gear train, the underlying principle remains a stroke of genius, converting the invisible, chaotic energy of an earthquake into a single, clean, and geographically specific mechanical action. The true test of any scientific instrument is its performance, and the historical record provides a stunning validation. The ancient chronicles tell of a day when a dragon facing west released its ball in the capital city of Loyang, even though no one there felt the slightest tremor. Skeptical officials dismissed it as a malfunction or an omen without meaning. But several days later, a messenger, weary and covered in dust, arrived from a commandery hundreds of miles to the west, reporting the utter devastation of a major earthquake that had struck on the exact day and hour the device had activated. This account confirms that Zhang Heng's seismoscope was not merely detecting local rumbles. It was sensitive enough to perceive the primary waves of a distant quake, waves that travel fast and deep through the earth, often unfelt by humans, and use them to accurately point the way. It gave the Han court a crucial head start, transforming disaster response from a matter of slow, unreliable rumor into a matter of swift, mechanical fact, a technological advantage in governance that would not be seen again for over 17 centuries. Now, let us turn our attention from the solid geometry of pyramids to an object that seems to defy gravity itself, a delicate wooden artifact that has ignited a fiery debate about the very skies above ancient Egypt. Discovered in the Saqqara necropolis during the excavation of the Pa-Di-Men tomb in 1898, this small, lightweight object is known as the Saqqara bird. Carved from sycamore wood and dated to approximately 200 BC, it looks at first glance like a stylized bird. It has a head, a distinct beak, and what appears to be the suggestion of feathers. But when you look closer, something seems unusual. The wings are perfectly horizontal and straight, unlike the angled, curved wings of a bird in flight. More strikingly, it completely lacks something found on every single bird in nature: legs. Instead of legs, it has a vertical, fin-like tailplane, a feature that is absolutely critical to one thing, and one thing only: the stability of a fixed-wing aircraft. This peculiar design prompted a radical re-evaluation in the 1970s, led by an Egyptian doctor and amateur archaeologist named Khalil Messiha. Messiha, who had an interest in model aircraft, was convinced the object was not a bird at all, but a scale model of a monoplane glider. To test this hypothesis, he and others built scaled-up, weighted replicas of the Saqqara bird. The results were startling. When launched with a little thrust, these replicas demonstrated excellent aerodynamic capabilities. They could glide for considerable distances smoothly and stably, a performance that seemed to rely on the very features that made it an odd bird: the straight wings providing lift and the unique vertical tail acting as a stabilizer to prevent it from yawing side to side in the air. For proponents of this view, these successful flight tests were compelling evidence that the ancient craftsman wasn't just carving a toy. He was replicating a design with an inherent understanding of aerodynamic principles like lift and stability, principles not formally defined until the work of figures like George Cayley and the Wright brothers in the modern era. The controversy deepens when we consider the mainstream Egyptological perspective, which offers a more grounded, though no less fascinating, interpretation. Scholars point out that the ancient Egyptians were masters of stylized representation. Their art was not meant to be photorealistic, it was symbolic. The Saqqara bird could very well be a votive offering or a child's toy representing a falcon, a bird sacred to the god Horus. The absence of legs is easily explained by its function. It was likely meant to be placed on a stand or mounted in a way that made legs unnecessary. The vertical tail could simply be a stylized representation of the bird's tail feathers, viewed from the side. They argue that seeing an airplane in this object is a classic case of pareidolia, where our modern, technology-saturated brains impose a familiar pattern, an airplane, onto an ancient symbol that had a completely different meaning for its creators. To them, it is a beautiful artifact of daily life and religious practice, not a blueprint for flight. Yet, the aerodynamic evidence is difficult to dismiss entirely, and this has fueled more speculative theories. If the Saqqara bird was indeed a model of a working glider, what was it modeling? Could it have been a copy of a much larger, full-scale glider used for ceremonial purposes, perhaps launched from a high ramp during a religious festival to symbolize the soul's flight to the heavens? Even more radically, some have suggested it points to a lost or suppressed knowledge of aerodynamics, a pocket of practical physics understood by a select few priests or engineers, knowledge that was never widely disseminated and was eventually lost with the decline of their civilization. The most fringe theories, often tied to the ancient astronaut hypothesis, propose the bird is a model of actual aircraft belonging to visitors from other worlds, a literal representation of advanced technology witnessed by the Egyptians. The true power of the Saqqara bird, however, may not lie in proving one theory right and the other wrong. Its enduring legacy is as a perfect symbol of the conflict between our modern interpretations and the silent, ambiguous language of the past. It is an artifact that refuses to be easily categorized. It sits at the boundary between known science and speculative history, challenging us to reconsider the limits of ancient innovation. Whether it is a sacred bird missing its legs or the world's first known model glider, it forces us to confront a tantalizing possibility. In a civilization that mastered stone, mathematics, and astronomy, is it so unthinkable that a brilliant, observant mind might have watched a seed pod spiral on the wind or a certain bird soar on thermal updrafts and through experimentation stumbled upon the basic secrets of gliding flight? The Sakara bird does not give us an answer, but it offers a profound and beautifully crafted question, a wooden whisper from the sands that continues to soar on the winds of our imagination. While we often imagine the ancient world as a place of muscle and sail, there was one inventor who glimpsed a future powered by vapor and pressure. In the 1st century AD, within the legendary Library of Alexandria, a brilliant engineer and mathematician named Hero designed a device so forward-thinking it feels like a modern physics demonstration. He called it an aeolipile, named after Aeolos, the Greek god of the wind, but we might more accurately describe it as the world's first documented steam engine. At its heart, the aeolipile was an elegantly simple yet profound machine. Picture a hollow metal sphere suspended between two brackets so it could rotate freely. Two L-shaped tubes rose from a sealed cauldron of water below, acting as pivots for the sphere, with their open ends bent at a right angle, pointing in opposite directions. The principle was revolutionary. A fire was lit beneath the cauldron, bringing the water to a boil. The resulting steam rushed up through the pipes and into the hollow sphere, where it had only one way to escape, out through the two narrow, opposing jets. As the steam violently expelled from these nozzles, it created a powerful thrust, much like a modern garden sprinkler or a releasing balloon. This reactive force, governed by Newton's third law of motion, for every action, there is an equal and opposite reaction, caused the entire sphere to spin faster and faster, roaring to life in a mesmerizing display of power and motion. Hero understood that he had harnessed something fundamental. In his writings, he described the aeolipile not just as a wonder, but as a demonstration of the power of air and fire. He had, in effect, built a rudimentary reaction steam turbine, a machine that converted the thermal energy of steam into rotational kinetic energy. The very same principle of jet thrust that would one day propel fighter planes and rockets was spinning a bronze sphere in an ancient workshop. This was not a passive observation, it was an active, engineered application of physics. The potential contained within that spinning ball of metal was nothing short of earth-shattering. In theory, this rotational force could have been harnessed. It could have been connected to gears and wheels to grind grain, to pumps to drain mines, or to saws to cut wood. The basic ingredient for an industrial revolution, a prime mover beyond human or animal muscle, was right there, spinning in the steam-filled air of Alexandria. So why did the clatter of industry not rise from the ancient world? Why was this brilliant spark not fanned into a flame that could have transformed civilization centuries before the mills of 18th century England? The answer lies not in a lack of ingenuity, but in the economic and social realities of the time. The ancient economy, particularly in the Greco-Roman world, was fundamentally built on the widespread availability of slave labor. Human muscle was tragically an abundant and cheap resource. For a wealthy landowner or the state, it made little financial sense to invest immense capital in developing and building complex steam engines when the operating cost of slaves was so low. There was no compelling economic pressure to innovate for the sake of saving labor. Furthermore, the materials technology of the era presented significant hurdles. The bronze used for the aeolipile was not strong enough to withstand the high pressures required for a more powerful, practical engine. Without the ability to create strong, pressure-tight boilers from materials like steel, any attempt to scale up the device would have ended in a catastrophic and discouraging explosion. The cultural context also played a decisive role. In the ancient mindset, technology like Hero's automata and the aeolipile was often viewed as a thama, a wonder or a marvel. Its primary purpose was to inspire awe, to demonstrate philosophical principles, or to serve as an impressive temple offering. It was a curiosity for the educated elite, a dazzling trick to entertain guests at a symposium, not a tool for boosting agricultural or industrial output. Knowledge itself was esoteric, held by a small, privileged class of thinkers, and not systematically disseminated for practical, widespread application. The intellectual climate prioritized philosophy and geometry over what we would call mechanical engineering. The goal was to understand the world, not necessarily to dominate and reshape it through technology. When the great library of Alexandria eventually declined and the Roman Empire fractured, this fragile thread of mechanical knowledge was simply lost, a brilliant but isolated branch of human thought that withered because the social and economic soil needed for its growth simply wasn't there. The Eolipile remains one of history's most poignant what-ifs, a silent, spinning ghost of a future that arrived over 1,500 years later than it might have. A powerful reminder that technological possibility alone is never enough to change the world. And now for our final and perhaps most earth-shattering example, we arrive at a windswept hill in southeastern Turkey, a place that doesn't just challenge our timeline of ancient technology, but the very story of civilization itself. This is Göbekli Tepe, a site so profoundly old and so utterly mysterious that its discovery has forced archaeologists to tear up their oldest textbooks. Its first stones were set into place around 9,600 BCE. To fully grasp how ancient that is, consider this. It predates Stonehenge by a staggering 6,000 years, and it was constructed a full 5,000 years before the Great Pyramid of Giza. But its age alone isn't what makes it the ultimate historical enigma. The true shock is that Göbekli Tepe was built by hunter-gatherers, a people we have always considered nomadic and relatively simple, who had not yet invented agriculture or settled into permanent villages. This single site turns the standard narrative of human progress completely on its head. What these prehistoric people built here is staggering in its scale and ambition. Göbekli Tepe is not a simple settlement. It is a ceremonial complex, a series of at least 20 circular enclosures carved directly into the bedrock of the hill. And within these circles stand massive T-shaped limestone pillars. These are not small stones. The largest pillars soar over 18 feet tall and weigh an astounding 16 tons. They were quarried from local bedrock, shaped with stone tools, and then transported, likely using log rollers and immense human effort, for hundreds of yards to the site. The pillars are arranged in a deliberate design, with two larger central pillars surrounded by a ring of slightly smaller ones, all interconnected by stone walls and benches. The engineering feat of erecting these colossal monoliths without the wheel, without metal, and without domesticated animals is a breathtaking accomplishment that speaks to a highly sophisticated level of planning and coordinated labor. But the mystery only deepens when you look closer. The surfaces of these pillars are not blank. They are covered in a stunning gallery of intricate carvings, a menagerie of the ancient world. You'll find finely etched foxes, snarling lions, charging wild boars, graceful cranes, crawling scorpions, and herds of gazelle. This is not random graffiti. The artistry is skilled and deliberate, a form of symbolic communication carved in stone. The T-shape of the pillars themselves is now widely interpreted as highly stylized human figures, with the horizontal bar representing a head and the vertical shaft a body. Some of the central pillars have carved arms, hands, and loincloths, suggesting they are abstract representations of powerful, ancestral beings or gods watching over the rituals performed within the enclosures. This was a sacred space, a temple complex built for a purpose we can only guess at, a cathedral constructed at the very dawn of humanity's awakening. The revolutionary implication of Göbekli Tepe is what it does to our understanding of civilization's origins. For over a century, the accepted story, often called the Neolithic Revolution, was clear and sequential. First, humans discovered agriculture. Farming produced a food surplus which allowed people to settle down in permanent villages. This settled, stable life led to a population boom, social stratification, and the specialization of labor. Only then, with these complex societies in place, did humans have the time, resources, and organizational skills to embark on grand projects like monumental architecture and organized religion. Göbekli Tepe shatters that sequence into a million pieces. Here we have the grand project first. We have monumental architecture and complex symbolic art created by hunter-gatherers. This discovery suggests a completely different catalyst for civilization. Perhaps it was the need to build and maintain this sacred place that forced hunter-gatherer bands to cooperate on an unprecedented scale. To feed the hundreds of people required to quarry, carve, and erect these pillars, they may have been driven to cultivate wild grains on a larger, more systematic basis. In this new narrative, the temple didn't come after the farm. The temple may have invented the farm. Organized religion and shared spiritual belief could have been the glue that first bound large groups of people together, creating the social structure and collective purpose that then made the discovery of agriculture not just possible but necessary. The very act of coming together to build Göbekli Tepe might have been the spark that ignited the entire Neolithic revolution. And then, in a final haunting twist, the builders of Göbekli Tepe, after centuries of use, deliberately buried their own masterpiece. Around 8000 BCE, every one of the stone circles was meticulously backfilled with earth, stone, and animal bones, perfectly preserving the site for 12,000 years until its modern rediscovery. Why was it a ritual act of decommissioning? Did a new belief system replace the old? Was it an act of preservation, sealing their holiest of places for eternity? We may never know, but this deliberate burial created a perfect time capsule, gifting us with the one piece of evidence strong enough to overthrow our oldest assumptions. Göbekli Tepe stands as a silent, monumental question mark at the very beginning of our story. It forces us to admit that the human drive to create, to believe, and to build on a grand scale is far older and far more profound than we ever dared to imagine. The origins of civilization are not a simple, linear path, but a mysterious and complex tapestry, whose first and most vibrant thread was not the plow but the pillar. And so, we arrive at the end of our journey through 35 moments that shatter the timeline. From the intricate gearwork of the Antikythera Mechanism to the self-healing Roman concrete, from the potential electricity of the Baghdad Battery to the nanoscale artistry of the Lycurgus Cup, the evidence is not just compelling, it is overwhelming. We have walked through the perfectly aligned corridors of the Great Pyramid, stood in the acoustically engineered spaces of Inca stonework, and witnessed the mathematical genius of the Maya, who charted cosmic cycles with a precision that humbles our own modern calculations. These are not isolated curiosities or lucky accidents. They form a mosaic of profound ingenuity, revealing civilizations that were, in specific and breathtaking ways, profoundly ahead of their time. The common thread weaving through all these marvels is not one of continuous, linear progress, but of brilliant, flickering lights. Pockets of advanced knowledge that flared into existence, illuminated their age, and were then, for reasons of catastrophe, social collapse, or deliberate suppression, lost to the shadows for centuries, sometimes for millennia. These losses point to a deeper truth about the fragility of human knowledge. The formulas for Greek fire and Roman concrete were state secrets so vital that they died with their last custodians. The conceptual leap of movable type, demonstrated by the Phaistos disk, vanished without a trace for over 3,000 years. The advanced surgical techniques of Sushruta had to be painstakingly rediscovered in the modern era. This pattern of emergence and disappearance forces us to abandon the comforting but flawed narrative of a straight, upward climb from primitive to advanced. Instead, we see a story of peaks and valleys, where knowledge is not a guaranteed inheritance but a precious flame that must be actively and vigilantly tended. lest it be extinguished by the winds of time, conflict, or simply a change in priorities. The achievements of our ancestors were built on a foundation of intense observation of the stars, the ocean swells, the properties of materials, and the human body itself. They combined this empirical data with dazzling intellectual leaps, creating technologies that we, with all our instruments, are only now beginning to fully comprehend, and in some cases, desperately trying to replicate to solve our own modern crises. This exploration is more than an academic exercise. It is a fundamental recalibration of our perspective. It is a call to look upon the monuments of the past not as the crude beginnings of our own superior world, but as testaments to a different kind of intelligence, one that mastered its environment with the tools and paradigms available to it. The next time you see an ancient ruin, a mysterious artifact in a museum, or even a photograph of the Nazca lines from the air, I encourage you to pause. Look beyond the surface and ask the deeper questions. Question the established narratives handed down to you. Who were these people really? What did they know that we have forgotten? What secrets are still locked within the silent stones and undeciphered scripts they left behind? Let a sense of wonder, not superiority, be your guide. History is not a closed book, but a living, breathing mystery, filled with clues waiting for the next curious mind to connect them. The story of human innovation is far richer, far more complex, and far more inspiring than we have been led to believe. Now the conversation continues with you. Share your own favorite ancient mysteries in the comments below. What artifact or achievement from the past fills you with awe and makes you question everything you thought you knew? Let's keep the wonder alive. And so, as our journey through 35 astonishing examples of ancient brilliance draws to a close, I want to speak directly to you for a final moment. Thank you for embarking on this incredible adventure, for lending your curiosity to a story that spans millennia and shatters our simplest assumptions about the past. If this exploration into the boundless ingenuity of our ancestors opened your mind to new possibilities, if it made you see history not as a dusty timeline but as a vibrant tapestry of innovation, then I would be incredibly grateful if you'd give this video a like. It truly helps this channel continue its mission to uncover history's greatest enigmas. If you haven't already, please consider subscribing and tapping that notification bell. We have so many more mysteries waiting to be unraveled, from lost civilizations and unexplained artifacts to the secret histories hidden in plain sight, and I don't want you to miss a single one. As we part ways, I'll leave you with one final question to ponder, a question that brings the entire journey back to you. Looking back at all we've explored, from the Antikythera Mechanism's celestial gears and Rome's self-healing concrete, to the potential for ancient electricity and the surgical mastery of Sushruta, which of these advancements strikes you as the single most mind-blowing? Is it the sheer conceptual leap of Democritus's atomic theory, born from pure reason, or the monumental, practical genius of Göbekli Tepe, a temple that rewrites the very origin of civilization itself? Head down to the comments and share your choice. Tell me which ancient marvel captured your imagination the most and why it resonates with you. I read every single comment, and I cannot wait to continue this fascinating conversation with you. The story of human ingenuity is far from over, and your perspective is a vital part